What's up, guys? Tim Austin with DragBoss Garage. Welcome, Darin Morgan. It's good to see you again. Hi, everybody. We're live, and man, do we have some great information to share with you. Here's what I wanted to say ahead of time, so we're not wasting time on Darin's presentation. But I put that video up about the most outlawed engine in racing history, which I got a lot of comments from that, a lot of information. But one thing that came up that was commonplace, it seemed, and I think we should dispel this, or at least educate people that don't know this, is the difference between a 351 Cleveland 4-barrel head and a Chevy big block Chevy head. So I asked Darin, I said, look, maybe you can say a few sentences on this so we can put it out on video so I don't have to keep explaining to people the difference and that it's not a copy.
It's kind of hard. They're more unalike than they are alike.
Interesting.
Actually.
I mean, I look at it and I say, well, look at the valve angles are different, right?
Oh, yeah.
Okay.
Absolutely.
I look at
the standard big block Chevy is 26, where you got 10 degrees on a Cleveland. And plus you've got rotation in the valves on a Cleveland where you have a little bit in a big block Chevy, but not much.
So what you're saying is that a Cleveland has way more cant than a big block Chevy. Valve cant, correct?
They're about the same in that regard.
Okay.
But the valve positioning and port positioning and valve, everything's different. I mean, I don't even know how anybody could draw a similarity between the two, tell you the truth.
What about the intake ports? Aren't Cleveland symmetrical?
Yes.
Aren't Pro Stock heads symmetrical?
Yes.
Okay. Why aren't they asymmetrical like a big block Chevy?
I mean, the port layout we use is identical to the port layout of a Cleveland cylinder head.
There you go. So there is a difference between a big block Chevy and a Cleveland. We don't need to waste any more time on it. We kind of got it right there. So one of the things that I saw, we're going to talk about the new Ford Pro Stock engine, which Darin helped design the heads, maybe the intake. He's going to enlighten us on that. And the car was just ran, or the engine was just ran in a Econo Dragster. What is his name? Neff, isn't it?
Yeah, Clint Neff.
Clint Neff. And that thing ran like 215 miles an hour. A 654 was what I initially saw. Then I saw it run a 652.
Yeah.
I mean, it's taken over the field, actually. What can you tell me about that engine?
Well, let me think here.
Because I know they only made...
Well, first off, this is up here. Can you see my cursor?
I can see it. I don't know what other people can see, but they'll chime in if they can.
This is the JC51, okay, that I had free reign with as far as the heads are concerned. And we'll get into who helped with the block and everything else. Basically, this all came about, the whole Ford program came about because of Jim Cunningham and Tom Sweeney.
Okay.
Who I don't have a picture of Tom, but they wanted a Pro Stock engine. They petitioned Ford. Ford says, we're not into Pro Stock. We're not going to do anything. And Jim said, I'll pay for everything. And actually, it came about that Ford actually volunteered FEA later on in the project, finite element analysis for the block. And I'll show you all the things that came out of that.
Okay.
But Tom Sweeney was instrumental in the block design.
Okay.
And other things as well. But the cylinder heads, this is the only time I don't even know if there has ever been a time when a head guy like me can come in to the Ford engineering facility and just say, I want this and I want it this way. And they actually not only did it that way, they actually, when you work with engineers, it's like they bring up things you haven't thought of yet, like the boss structure. And I'll show you how when we stress the head in FEA, why it's structured in the way it is. But it was a team effort, and all of us drove up to Michigan every weekend and then every other weekend for months and months and months. And we just sit around a design table, and the Pro Stock guys sit there and say, okay, this is what we want. This is what we need. And Ford just gave it to us. Everything we asked for, plus some we didn't. So this is the end. This thing is the end result of that.
What year are we talking? So we can all
2007.
2007. Okay.
Yeah, this engine's been around for 13 years now. There have been people trying to get them together. Now, Clint Neff I've been friends with Clint since, we were teenagers. So he asked if that thing could set the AED record. And I said, yes, hands down, no problem. I said, but getting the parts is going to be a little difficult. So what he did is for 2 years, he went out and scoured the United States and found every JC51 part, block, cam, heads that he could get. And he has the original 10 or 5 sets of heads that are exactly the way we cast them at Profiler, which is slightly different than they are now, which is a whole different story we won't go into.
So you were working at Profiler then
when
this came down. Okay.
We actually, at Profiler, I often said that you could get the raw ingot in the back door and ship the finished head out the front.
Wow.
I mean, everything was done in-house.
I mean, they could heat treat there and everything.
Yeah, everything.
Wow.
So we cast it, machined it, everything right there.
Now, what's the JC50? Now, that's a current Pro Stock head?
Yeah, let's go back to this picture. This is the JC50 down here. It's a hemispherical design.
On the right lower corner.
Yeah, or a semi-hemi is what they call it. It's not really a hemi, but you get the drift.
Mm-hmm.
And you can see the valve train layout, port layout is radically
way different. Yeah.
Different.
Yeah.
This cylinder head right here is a mimic of the Mopar Hemi, except the valve train has been moved some. Spark plug locations are different. They just changed things that Larry wanted. And how the JC50 came about was we were already done with the JC51. We were already, it was off to the manufacturer to cut the cores.
Okay.
And Larry said, I don't want to use it. And, I kind of asked him why. And he said, well, all my R&D is around this Hemi. And if I start over, there's a chance this thing won't run. And he was right, 100% right. And I can't fault him for what he did, because he wanted to hit the ground running instead of spend 6 months to a year on a new combination. Well, little did we know this thing was going to do this. I mean, it's performed beyond expectations. Let's put it that way.
I mean,
the first time on the dyno, it just, made 1400 without effort.
And that's the same dyno that other racers use in that same class?
Yeah. Now, this engine is, the Dragster engine is really limited by the carburetor. It's got one carburetor. So it's having a hard time breathing over about 10.5. But that's not to say that I'm not going to get it there.
And I won't jump too far ahead, but people have been, I mentioned what you told me that, this is a 499.6 cubic inch engine. We'll call it 500. Okay.
Yeah.
Bottom line is
call it 500.
14 and a quarter. You put a tunnel ram, another carb, you get 25 horsepower. You make it a wet sump, you get 25. You get 15, there ain't no more. Simple. You ain't making no more than 1,500 horsepower. Whoops. Sorry, guys.
No, I mean, the physical limit is 130% volumetric efficiency the limit on torque for a gasoline burning engine is 1.65 foot-pounds per cubic inch. So the name of the game is to take that 1.65 pounds per cubic inch and raise it higher and higher and higher.
Okay.
Well, there's a limit to that, especially with a pushrod engine. And if you would have told me 20 years ago they'd be hitting almost 12,000, I would have scoffed at that, but that's realistic now.
12,000 RPM.
Yeah. I mean, what I knew about valve trains 10 years ago is old news. Billy Godbolts.
Yep.
I mean, he can, well, let's put it this way. He's so good that you could call up and get a cam, put it in a rail, and go set the record like he did, like Neff did.
Yeah.
And have that valve train stable to 11,000. We sent the heads to Jessel and had them put the good rocker gear on there.
Yep.
And what everybody in this game specializes in what we do. There is no one-man show. I mean, I do heads, Jessel does valve train, Billy does the cams, and everybody has their specialty. I always say I'm not an engine guy. I'm not a valve train guy, but I can hold my own, obviously. The valve train also on the Hemi was an issue because the push rods and the lifters aren't exactly in plane with each other. There's
I'm looking at it now.
Compound angles, and anytime you have an angle off that lifter, the movement is going to increase, and that deflection will increase, which lowers lift and increases the system's ability to create harmonics in the system and rattle shit and do all sorts of nasty stuff. So the whole idea is just to get everything as straight and in plane as possible. Then the Hemis had a problem, and then the Johnsons worked on it, and they had them turn in 11,800. The problem with the Hemi is, and we knew this going in when we designed the Ford head, I'll go through why we did what we did and then how we did it. So this is a wedge cylinder head. What you're seeing here is basically the airflow path through the cylinder head.
Okay.
As you rotate the valves around the combustion chamber, that line gets straighter and straighter and straighter until you get to a Hemi. So if you think about it, this would be like a standard big block Chevy.
Got it.
And this would be like a DRCE1 and a DRCE3, and that would be like the semi-Hemi. So between this right here, this airflow path to, from this one to this one is 1,000 RPM.
Wow.
This Hemi chamber wants to run 1,000 RPM higher. Now, why is that? Why does valve positioning actually dictate where the engine wants to breathe?
Maybe
as you rotate them around, the engine's VE curve wants to shift higher and higher, or you can create VE higher and higher because you're moving air easier through the engine.
Okay.
Well, if you have this Hemi head like this, and you try to make power below that, you're going to have the engine's actually going to act like it has too much duration. The overlap, it's going to kill all the torque. And the Hemis were gutless. I mean, horrible on torque down low, until Johnson's worked on it and got the power band up to where they could get the torque to come in with the cross flow here. So
now, who are we talking? When you say Johnson, who are we talking about?
Alan Johnson?
Yes. Okay. I want to make sure we're all clear. Yep. That's amazing just to be able to do that on this.
Now, see, if you look at this, a wedge head, this thing, these engines won't run past about 9,000, 9,500. That's all they got.
Yep.
And then you go from that to like this, and now you've got about 96, 9,800. And then you've got 10,000, 10,2, 11, 11,6, 12,000. Wow. So we are actually designing the cylinder heads with valve placements that correspond to where the engine runs.
Now, this is exactly why you change valve angles and position when you're making custom race heads. This, you know what I'm saying? Like, so what they did back in the day, in the old pro stock days, rotated valves, moved them different to get this plane so that we could get this path.
And these heads are 9.5 degrees valve angle with 2 degrees of cant.
Okay.
So they're very shallow combustion chambers. And if you looked at the Hemi, the Ford, the DRCE3, the DRCE1, all those chambers are probably within 5 to 8 cc's of each other. They all look identical. They all look the same, basically.
How big are they? How many cc's in rough? 90?
No, 54.
Okay.
48 to 54.
Wow. That's small. Damn. It's almost like a Yates head.
I'll show you some. You'll see. The DRCE3 project. And by the way, there was an article that came out in Drag Illustrated, and there was a couple of misprints in there, and I'd like to get this straight. One, he mixed up the JC50 and the JC51.
Okay.
To stipulate, the JC51 is the Hemi, and that has been run by a lot of people. The JC51 is what they call the wedge, which it's not. It's a rotated cannon valve. But the only time this engine has been run is in Neff's Dragster.
It's like a new baby, you know?
Yeah. And the other thing is he mixed up the DRCE2 project and the DRCE3 project, because when I told him that I had called Warren about the DRCE3 project, he put it down as the 2, and Warren and I had spoken about 3 or 4 times.
Now, Warren Johnson you're talking about.
Yeah.
Okay.
But for some reason, he rolled it in and said that we'd worked closely together. Warren and I have never worked together. So let's get that straight.
Yep. There you go, guys.
This is the basic valve placement relative to the dowel and bore center for the DRCE 3 cylinder heads. And you can see that's quite a bit of rotation.
Oh, yeah.
And this is the Ford. It has a little less rotation. Now, at the time, in 2007, we were just getting wise to the valve rotation relative to engine RPM, engine speed.
Yep.
So at the time, what I did was I've made this cylinder head to where you can rotate the valves 4 degrees either way. The water jacket is big enough that you can do that. And it also has valve bosses and everything else to where you can move that in that plane and not get outside of the water jacket and then have to weld and do all sorts of stuff.
When you move those valves, when you put new guides in, I mean, do you have to weld up the head and then re-drill to put the guide to move it all the way over where you want to?
No.
Not necessarily.
Well, if you mess it up, yeah. If you blow it up, yeah, I just dig it out, weld it all up, and then put it up on the mill and punch them.
But normally, if you do it right, you don't have to do all that.
Yeah.
Change it. Okay. What's up, guys? Good to see everybody here. Jeff Straub, Clint Meister, Gregorius Anomalous. Everybody's here. We got 145 people listening to this, so this is really good. Thanks, Darin.
This is the DRCE3, and the DRCE3 head was end block and things were, well, let's just say it was fraught with difficulty.
Okay.
There are a lot of things on there. We didn't get what we wanted. And when this Ford program came about, I talked to Sweeney and I said, we're going to get everything we want. And he was very forceful as well. And we didn't need to be, because they were just like, hey, just tell us what you want and we'll do it.
That seems
everything, every single thing we wanted. So this is the DRCE3. You can see this lighter colored peg right here is the original location for a 1. Yeah. Yeah. And then the 2 moves it over, and then the 2 and the 3 intake valve location is very similar, and then the exhaust is rotated around.
Okay, yep, I see the 2
forward. There. But what this does is it causes a couple of issues because of the valve train, which I'll show you later, how we moved the lifter bore bank angles and all that stuff to get this all to work. But you have to run a real long rocker over here. And at the time we were doing this in 2007, 2008, 2009, the valve train technology, a long rocker has a high polar moment of inertia. It's got a lot of mass on the tip. So you have to return that every cycle. So the problem is the springs and everything weren't really capable of handling a long rocker at really high engine speeds. Okay. Now it's child's play. It's no big deal.
What was high engine speed back then?
Do what?
What was high engine speed back then?
Peak power at 9,800, 99.
Okay. Okay.
So like a 10-2 shift point. But see, once we started going from 55 to 60 and then 65, and the Ford block is actually capable of a 70 millimeter core.
Okay.
So that's a 3-inch diameter cam. So you could put a 700 lobe in that thing.
Wow. Lobe lift. Times the ratio.
This is the DRCE3, and it has a lot of angle on the exhaust.
Oh, yeah.
The intake is perfectly in plane, but the exhaust has a lot of angle to it. And that is a little bit problematic. But on the Ford head, we got around that. Of course, we had to have custom everything, custom core, billet cores. I mean, the valve train is different than anything in the world.
It's amazing.
And this is, you see here, a Hemi, a true Hemi, and the DRCE1, and then the 2 is rotated a bit. And then the Mopar. But see, the chamber shape is the same.
But I do see the valve rotation between 1 and 2.
Yeah.
When I look at that picture.
The chamber size and the chamber shape is the same.
Wow.
It's just rotated.
Now, Mopar semi-Hemi, that was where they moved it to almost a regular full Hemi, where it was pretty darn good.
Look at that. There's the wing. The intake port is right here. So it's shooting right out the exhaust.
I wish we could point to things, you know. Can you see that? Can you see that if I point to that?
What?
Where I'm pointing the cursor. Can you see that?
No.
Okay. But I see the wing there coming up, the port. That's great.
This is a DRC E3 is what this is. And see the quench area on this thing? See how that chamber, I think, was 46 cc's?
Wow.
No, that's the semi-Hemi. I'm sorry. That's a set of heads I did for Larry years and years ago. That is a semi-Hemi.
Now, what is that? Beryllium seats?
Yeah, we don't use beryllium anymore.
Okay.
Some people do.
Yep.
Matt at MB still uses beryllium.
Yep.
It's better, but it's 5 times more expensive.
And it's, you know, cancerous. You know what I mean?
Yeah, if you breathe the dust, it is.
Now, what's the other port, the intake? What's that metal?
What?
Well, the one is beryllium. The exhaust is beryllium.
No, that's I forget what material that is. It's actually just CHEBX material on the exhaust.
Okay.
And that's A material on the intake, which is just something you can call CHE and order.
I like it.
And here's another picture of the semi-Hemi Ford. This is the actual Ford head, which if you had the Mopar and this side by side, you'd be hard pressed to tell the difference between the two. And here's a good shot of the valve train. Now, we got rid of a lot of the angle on the exhaust. The lifter boards are spread out enough to where we could get everything on this valve train completely straight, almost completely straight. It does have, I forget, like 4 degrees of angle on the exhaust, which is no big deal. But the intake is dead straight. And the lifter bores are only about 3/4 of an inch below the deck. So you have very short push rods. This is the raw heads. This is the way, if you call up Ford and order these heads, this is how you're going to receive them.
Okay.
They're raw castings. I think they're about $2,500 a piece.
Wow.
And then you send them to me or somebody and have them machined up and you know, do what?
Another 10 grand, you're good to go.
Yeah, I think you could get them done, machined and everything for probably about 19,000. Wow. That's complete with valve springs, retainers, locks, minus valve train.
I mean, think about the valves alone, you know, 100
I mean, they're expensive, but for a pro stock head, that's not that expensive. It really isn't. And, you know, some people are calling Neff's car the $1 million car. It's like, if they only knew, he scoured those parts. He got those parts. He doesn't have any more than about 75,000 in that engine. Wow. That whole car is under $100,000. That whole car.
Sweeping the field right now. You know, how long that'll last, you don't know.
Clint's pretty frugal. He's not going to blow money where he doesn't have to.
Here's a question. Could either of the JC version engines be competitive today in NHR Pro Stock?
In NHRA Pro Stock?
With fuel injection?
Absolutely. No question.
Okay.
As a matter of fact, that might happen.
I was thinking that. Definitely.
Well, Clint has, I think, 3 engines. Of course, he used this cylinder head on his K altered, which is a 4-cylinder. It's a 250 cubic inch 4-cylinder turning 10,800 RPM, making 650 horse.
With this cylinder head?
Yeah, with this cylinder head. And he set the record, and he's raced comp with that forever. And he's also got 2 bullets. He's got one complete in the car now and one going together. So he has an extra engine that we can put in a pro stock car. And there are talks going on right now about that.
Nice. Very nice. I think aluminum's my favorite metal.
Oh, yeah. I hate cast iron.
What's up, guys? Unity Motorsports. How you
This
doing?
is Clint Neff's cylinder head and manifold. As you can see, the total runner length is right at 9 inches flat.
Wow.
To the valve. So, I mean, its tuned power band is really from 9,000 on up. I mean, this engine doesn't even start to run until 8,000 RPM.
That just blows me away.
And you can see that I made the whole head solid up here. And actually, there are bosses that go down through here to tie in. So the stress of these bolts up here is tied into the deck. You're not pulling on the top of the head. That stress is transferred down into the casting. So that's less deflection.
You can't see it when you're pointing to it, but what you're talking is inferior below the exhaust ports. You can see the bosses for the bolts, for the head bolts. Is that
it's actually in the water jacket itself.
Really?
Yeah. You know, usually you just put the cylinder head and you put a bolt down through it. Well, the bolt goes into a boss that goes down and transfers that stress into everything else around it.
So the water's going around that boss.
Yeah.
Okay.
And as a matter of fact, you can look in one end of this cylinder head and see daylight out the other. It's a straight shot for the water.
Right.
The reason we did that is, and this is where the Ford engineers come in, because they did all that NASCAR water flow stuff. So we sat down with those guys, and where the intake side of the cylinder head is, where the bowl in the water jacket is, it's smooth on that side. And everything off around the spark plug in the chamber, there's recesses in there. So as the cold water is shooting through the center of the cylinder head, it's sitting there swirling around the chamber and around the spark plug boss. And it comes out the other side. So the temperature delta from one end to the other is minimal compared to any other head. Okay. Now, I don't have any data on that, but supposedly it's supposed to be better than anything. And Clint said that he can't tell the difference from one end of the head to the other, because right here you have an exhaust port and there's water jacket right here. So the water comes in on the in port here and cools that one first. Okay. And it actually goes around both sides. And then here, that's blocked off and it boils. Also, the oil returns. See this hole here and this hole here? Those are oil returns. We incorporated everything into the head, so you don't have to have any hardware on the outside. Those holes, those oil return holes, go down through the block into the crankcase and dump away from the crankshaft throws. So it's not picking the crank isn't picking that oil back up.
Okay. Yeah, we can't really see where you're pointing to, but I see on this
my cursor.
What's that?
Do you see the cursor?
I don't see it.
No, it's right in the ends of the cylinder heads.
Yeah, I see it now by the head bolts. Right
Yeah,
corner there. Yep.
Yeah, these right here are the head bolt holes.
Somebody was telling me that you can make a bunch of power, free power, if you optimize your water, your coolant flow, and make sure that everything's the same temperature, like you're talking about the delta change going from one end to the other, because each cylinder is making different horsepower because of the different temperature. Am I right?
Yeah, and in this game, it's detonation sensitivity.
Okay.
You need to keep your chamber temperatures as uniform as possible and down, which is another reason why we ice the engines between in Pro Mod or Pro Stock. Anything that is right on the edge of the fuel's capability.
Yep. With
compression and cylinder pressure, where it's just right on the edge of trace detonation and can get away from you, like a Pro Stock or a Pro Mod nitrous deal. The chamber temperature is critical.
Really?
It's highly critical. As a matter of fact, if you don't cool a Pro Mod engine down correctly before a run, you won't make it past the 8th mile mark before it burns the pistons out. I mean, that chamber temperature's got to be correct. That's why you can't burn them down on the line either. You don't see starting line games with Pro Mods. No, they'll burn up.
Now, I've never heard this before. What do you think? Have you seen this before? Need to try carbon fiber rods and pistons.
Let's talk about that a little bit, shall we?
Oh yeah, let me put it back up there. Yeah.
Okay. I have never seen, nor do I know anyone who has ever seen carbon fiber push rods or pistons function for more than seconds. It is not to be used as rods, carbon push rods, or pistons. It will not work. It has not worked. It has never worked. As a matter of fact, we just got carbon fiber. Some guy sent us part carbon fiber push rods, and you turn the engine over and, well, you can see the deflection. So, really? Yeah. As a matter of fact, the 2 times that I know of that people have tried carbon fiber push rods, if you ever hit a certain RPM or engine speed that they're not happy at, they turn to dust. They explode. They literally explode. They won't take harmonics at all.
I mean, look at a carbon fiber drive shaft. That's why you use one, you know? It doesn't take your legs off.
And actually, when's the last time you saw a carbon fiber manifold on any pro car? You won't.
Nothing.
Because they don't run.
Okay.
The fuel wall wetting is horrendous with them because it's a glue. It's polished.
Sure.
So they're detonation sensitive right off the bat. Plus, for some reason, unbeknownst to us and me, the aluminum manifolds make more power. They always have.
Okay.
And if you make a manifold out of metal that's too thin, it will resonate and put a hole in the power band, kill the fuel signal in certain parts of the. So the thickness of that metal and how that manifold vibrates, resonates, is very, very important. And as a matter of fact, you can build a manifold that'll resonate so hard it will literally foam the fuel in the float bowls. It'll shake the carburetor so hard it'll just go to foam, and the engine will lean out. Yeah, the manifold building is not just the shape. It has to do with the metal you use, the type of metal you use, because there's different types of aluminum that you use. Okay. A different type for the plenum, different type for the flanges. Yeah. It's a lot more complicated.
I've never even heard this before. It's great to hear.
That's because nobody talks about it.
Yeah. You're going to see it here at DBG, guys. Thank you. Well, there you go, Justin. Hopefully that answered your question.
Now, Lump did this manifold before he passed.
Who was that?
Lump.
I don't know. Lump. R.I.P. Lump.
Huh?
I said R.I.P. Lump.
Brian Self.
Okay, I think I've heard of that guy.
Yeah, Self Racing. He's been around for since.
Was.
Yeah, was.
That's amazing.
So that's his work. Some of his final work, I think. Okay, you can see the push rod angle on the exhaust is very, very little. And the intake is dead straight.
Yep.
And here you see these bosses right here, the bolt boss. The one thing I didn't want to do is go down through the port with a bolt.
Show me where, because people can't see where you're pointing. Kind of give me like where the.
Can you see it now? Can you see my cursor?
Nope.
No.
Nope.
I don't know how to bring up a cursor here. No.
Just give me a landmark that we can go by.
See in between the two lifters?
Yep.
The bolt?
Yep.
You see they're strutted on both sides?
Yes.
Okay. That's designed in such a way that a 12-point wrench will get exactly 1/2 turn.
Okay.
Because I needed the struts for support on that boss because I didn't want to go through the port because I hate that. It just makes the head so much harder to work on. So this head, you can get off and on the engine twice as fast as a DRC E3.
Damn. That's amazing.
And this is, some of these I'm showing you are not the actual CAD images.
Okay.
These are renditions of CAD. This is an earlier version. You notice it's not flat and all filled in. Mm-hmm. The spark plug, the amount of rotation we had, I wanted to bring the head out and incorporate the oil returns and everything else. And the plug position was pretty tight, as you can see. It's right up against the rail.
Oh, yeah.
And there you can see. And this is with the short rocker. With the long rocker, this moved back and actually got a little bit better. That's about 3 degrees less than a DRC E3 has to put up with on that push rod angle. This doesn't show the bolt bosses, but I know there it is. That's the bolt boss. Now, this bolt boss was designed in FEA, finite element analysis. They stressed the cylinder head in the FEA software. So all these struts and this whole design is done there.
Wow.
As well as the block. They found funds later on that they put the whole thing through FEA, and they also did lithographic models of it. So they literally made plastic models in actual size of the head, the block, the valves, the pistons, everything, crankshaft, and assembled the engine in plastic before it was even done, just to make sure of the fitment issue. We didn't have any fitment issues. This is what happens with a short fulcrum rocker. The rocker we have in there, these are 2.5s. This is moved back to here, which puts the push rod more in plane with the lifter as they are now. Again, these are earlier pictures.
Where you're saying where the rocker is sitting on top of the fulcrum. Is that what you're talking about? Okay.
And this was in 2007. This was just as everybody was going to the solid bar, flat mounted valve trains. And at the time we were using the 5-bolt. So it's 4 5/16 on the outer and 1 7/16 14 in the center.
Okay.
That's what we were using. And this, of course, is not as structurally sound as the solid bar is. You can't beat the bar.
That's a lot of bolts to hold that in, you know?
I always say you can't have too many valve train bolts. That's impossible. I mean, just on the super stock Hemis, adding 2 or 3 bolts to the valve train took it from 94 to 9,600 RPM without dropping a valve. And those things were really bad about dropping valves.
I hear someone asking a question. I don't know if it relates to this or if we want to answer it now, but it kind of goes into what you're talking about. It's something you said before. See if you can tie this in. In a podcast a while ago, you talked about how once the depression on the flow bench reached a point, the rudder became a bored hole right to the valve. Port shape no longer mattered. Not sure how to interpret this.
I said that port shape no longer mattered?
I guess.
I can't imagine me saying that.
Yeah, I know.
If you would, please, Mr. Savage, email me a link to that, and you and I will talk about that.
There you go.
Because I hope I didn't say that. Now, I might have been alluding to the fact that once the valve hits about 0.4 lift to diameter ratio, it's out of the way. And you'll actually see on the flow bench, you'll see the flow curve jumps up and then it kind of levels off. But about 0.4, 0.45 LD ratio, it'll take off again. And that's where the valve is out of the way. You could literally pull it out and
have the same flow.
It's almost like the port doesn't see the valve there anymore. It does a little bit, but you get the drift.
I think that's probably what you're talking about.
It becomes, instead of curtain area, it becomes all throat area at that point. This is how far down the lifters are from the deck. I think it's like 820 thousandths.
Wow.
Okay, this is, and by the way, I'm going to back up all the way to Buddy Morrison at Rear Morrison, who was the first one to do this.
R.I.P. Buddy.
He noticed that the push rod angles on the big block Chevy are acute. I mean, they're high, especially when you try to move the port around and make it straight.
Right.
So these push rods right here, see, this has a lot of angle on this intake. All you have to do is take all the lifters from this bank and switch them.
Okay.
And everything goes straight. Basically, that's it.
Now, can you do it with colors because people can't see you pointing at anything?
Okay. You see the yellow lobes on the camshaft?
Yes.
Okay, that's where they were moved to.
Oh, now I got it. Okay.
So if you take the exhaust or intake push rod on the top and move it over to the yellow, you'll see it goes straight.
Yes.
And if you take the intake on the other, move it to the yellow. So basically, this is what a DRCE3 valve train layout is what Buddy Morrison was playing with. And this is before we had cams and the valve train technology to really utilize that.
Was he doing this back when they were doing pro stock with Lee Shepard driving?
No, this was 97.
Okay. All right.
1997. 96, right in there.
Yep.
This is the top of the JC51 block. Now, the whole thing, again, I told you, has been through FEA, which means every bolt boss has been modeled in its distortion and pull on the block and how it moves the metal has been modeled within the software. So anywhere you see a bolt, you'll see a strut moving across from it.
Yeah.
Everywhere. Anywhere you see a bolt, especially on the side of the block too. And by the way, this is capable of a 70 millimeter core.
Wow.
So you could put 1-200 lift on this thing and spin it over 10,000. Easy. Not a problem. You notice how the caps are wedge shaped? The main caps.
It's hard for me to see the bottom of it the way that it is on the computer, but I can see it in my head from another picture that I have.
Another picture of the valve train bores. Again, these are early pictures. These are not the final ones. Now, here's the caps down at the bottom. You see the slot in the cap?
Mm-hmm.
Okay, that is for a partitioned pan. And the reason they're shaped the way they are is it makes it very easy to design a partitioned pan that slides down and wedges on them and seals really, really tight. Now, trying to make a segmented pan with an old cap is really a pain in the ass because you got to scallop it all out and try to seal it up. So we wanted to make it simple, simple, simple.
But you're saying the pan comes in contact with the main caps.
Yes, and each individual cylinders are an individual sump stage.
You would think the harmonics would be crazy with that metal to metal with the rotation of the crank and that pan just sitting there with hot oil in it.
It's siliconed on there.
No, but I mean, as far as like vibration, you know what I mean? Being transmitted to the oil pan from the crank.
There's never been a problem.
Yeah. Wow.
If you look at the X's on the side, the cross strutting down near the main web, that's all through FEA. All of that is. Instead of making it solid through there, they could scallop that out and put strutting in there and make it just as strong and save about 10 pounds out of the block.
So somehow they run it or they put the forces on it through this process and say, hey, we have a weak spot by the third cylinder by the main cap. We better put a strut in there and make the metal thicker there. Yeah. That's what they're finding. Okay.
If you look up, just Google FEA, finite element analysis, and you'll see what I mean.
I'll write it down.
It's the stresses are represented by differences in color. It's really cool.
Yeah.
The pan rail, as you see, is very thick and very wide, yet you're still able to see the O-ring groove around there? You're still able to go past the O-ring groove because on some pans, what you'll do is in the direction of rotation, you'll scallop out that side.
Okay.
Instead of just having your pan rail there, you'll scallop all that out and let the oil shoot off into the side, and that helps windage as well. Okay. It also, if you notice, has a sealed cam tunnel. No oil drops down on that crankshaft.
Wow.
And there is the sump stage for the cam tunnel, and everything else is built into the block. Just hook it up and go.
Why did they make it wet sump versus having it be a dry sump only?
Well, the rules call for a wet sump.
Got it.
In Econo Dragster. Instead of a dry sump and 2 carburetors and a 5-speed, you have 1 carburetor, a 2-speed automatic, and a glide. Or a glide and 1 carburetor, a glide. Now I'm drawing a blank.
Listen, guys, you got
to wet sump
because we're going to have a couple girls in here. So you guys got to bear with me for a minute because I want to.
We found a toad.
Okay, relax.
Yeah. Hi, it's my birthday, everyone.
Okay.
Yo. I'm 11, and this is my friend Olivia.
Hello, Olivia.
Yep, we got a toad.
Yay, baby toad.
Say hi to everybody, and
There's a newcomer.
okay.
My shoe fell off.
Okay. You remember Darin? He has the rabbits. Remember?
Oh
Yeah.
How are your rabbits doing?
They're doing well.
Good night.
You saw that one screaming bloody murder, didn't you?
Yeah.
We don't do that anymore.
Good night, Dad. There's a new comment.
Okay, we're all right.
I
So we're all 202 people here watching this right now. Yeah,
Wait, so they all know it's my birthday?
200 people know it's your birthday. And now we're talking engines.
I have a toad.
Nice.
Hi, everybody. Mr.
All right, guys.
This is the finished block right here.
I love that thing, man. I'm looking to see how many head bolts there are. It looks like,
The head bolt pattern is unlike anything else too.
I don't know how many there is. It looks like 8, but I can't. There can't be 8. 1, 2, 3.
There's five a cylinder.
Is it? How many are there?
5 a cylinder.
Okay, it looks like more. Sorry about this noise, but it's
Basically got the Ford bolt pattern with the out.
Yeah.
Yeah.
Bye, guys. Love you.
All right, I'm ready for questions if anybody has any.
Okay, let's see. I'll go back up because there's been quite a bit of questions, and here's one for you. This is kind of an interest one. One bad 50, baby.
Well, nowadays I don't know. I mean,
Exactly.
factory backing isn't something that's out there anymore. So
Now, here's something that he told me on a comment section from another video, which I was unaware of, but he told me that you pick up, I want to say 30 horsepower by going from a Cleveland main to a 302 main. Is that true?
well, it depends on what 30 horsepower is a lot. At 10,000,
Well, we didn't really say RPM wise. He just said by going to that smaller main.
well, it depends on engine speed and
Okay.
oiling system and bearing width and a lot of other things. But yeah, it's definitely worth power. Absolutely. At higher engine speeds, 9, 10,000. Absolutely.
So you're not going to see anything at 6, 7, 8.
No, you're not.
That's all I need to hear. All right. Let's see who.
I mean, in pro stock or comp engines, we'll
Yep.
actually take the bearings and narrow them. And we narrow them right up to the point where they're just about to burn up and then back off. Because literally, if you take 50 thousandths off all the bearings, it's like taking one bearing out of the engine. The surface area alone.
as far as the friction and surface area.
Yeah.
Wow.
Well, there's your through 2 or 3 horsepower at 10,000 RPM. It's free.
These are all good tips to know. Let's see
It's
what else.
all those little things that add up.
Let's see. This is what we were talking about with back in the day. We frigged with external plumbing in attempts to even out cylinder temps in small block Chevys. Yep.
Yeah. It's always been an issue. I mean, trying to get cylinder heads to cool evenly has always been a pain in the ass.
I never knew it mattered that much, really. To tell you the truth.
It does. It does. In a lot of ways, it does.
Let's see. I don't know what this one is.
I mean, we had to put up with, in the early pro stock days, we had to put up with steam. We literally drilled through the top of the head and routed 16th inch brake line out through the head to purge the air because it would explode in there. It would cavitate.
What it
And actually-
knock, bang, 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 you know?
Yeah.
Vizard experimented with Windsor Brand A series push rods. That's what David found. You had to test them and the failure rate is high. There it is.
The failure rate is guaranteed.
Bingo. Do they even make them?
They've tried.
Okay, let's see. Somebody, this is kind of funny. Will they fit on the DragBoss or Titus blocks? I don't think so.
No, this engine is its own animal. There's
the
nothing on this any other engine in the world.
What's the bore space?
4.9.
Okay.
Anywhere from an 8.8 to a 9-inch deck.
Here's an important thing that we talk about here. You don't see on other channels is this right here. It's not only the physical attributes, it's the physics, volumetric efficiency, airflow, numbers, tie it all together. This is what you see on this channel. I love that stuff. And hearing it from you, who can explain it to an idiot like me, where I can understand it.
It's never one thing, you know. It's people cover their manifolds and all that other stuff, and it's like there's no way you're going to walk up to somebody else's pro stock pits and go, there it is. there's the magic I've been waiting for. I'm going to go home and put that on my engine. No, it's 100 little things put together that extracts the power from these combinations.
Here's one.
It's like cutting, everything from, 130 radial 26 thousandths ring, gas operated rings that will literally fall through the bore if you let them in there. I mean, there's no ring drag in these things almost at all. It's all gas operated, which is why the oiling system and the windage and the amount of oil you can control is so damn important too.
Sure.
Because with no ring tension, you can't have a lot of oil in there. I mean, you need to pull about 24 inches of crankcase pressure to really reduce the oil mist down.
I mean, that's what they told me about vacuum pump. You're not going to really see much unless you're up to 18 to 19 to 20 inches.
The first 14 to 16 inches is about 20 horse.
Okay.
And then going to 20, 24, 26 inches is probably another 8, maybe 10.
So 14 to 16.
The reason that works is a lot of people think, well, you're lowering the crankcase vacuum and that helps windage. But you're also, people think about the pistons are pumping air in and out of the top of the cylinder. Well, they're pumping air back and forth in the crankcase too.
And they can come down easier and draw. Yeah, I can get it.
So if you lower the density in the crankcase, they're not moving any air. That's pumping losses that are reduced, and that's just free power.
Wow. Let's see. There's a question here. How important is line of sight from a throttle body to the runner entry? Is it beneficial to turn a runner slightly towards a TB over keeping it completely straight, towards the throttle body over keeping it completely straight?
I'm afraid this is going to be situation dependent, number one.
Okay. Yep.
But line of sight is a very important aspect of designing the induction system. It's one thing that we do concentrate on because your line of sight, or what we refer to as the window area, how much valve can you see? How much air, how much valve can you see? If the more valve you can see, the less the air has to turn. I guess you can quantify it that way.
And this goes to that. This is part 2 of that question.
But let me back up there.
Yep.
You need a straight runner. It's a necessity, but you also have to have a short side to turn the fuel. So if you look at direct injection heads now, they're aimed just straight down. They don't have a short side radius to speak of. They're like those ports are designed for high swirl.
Okay.
A lot of mixture motion at a low engine speed for fuel economy. Those are not racing ports. Those will not function in a racing engine. Because when you there's only so much energy available. So if you use some of that energy to swirl the mixture, your mass flow drops. You can't get around that.
Give or take. You get one or the other. With an inline 6 engine, would an intake plenum with throttle bodies on each end balance the plenum and flow into a runner entry?
Bill, I've never been asked this before. Yeah, it would. Yeah, it would. And that is a problem.
There you go, Sean B.
Hell yeah, it would. I think that's a hell of an idea. Go for it. Let me know how that works out.
I don't know what this is. Daniel Wilson, what's up? How many Ford Pro Stock teams are currently running in NHR? I don't know if any, really. I don't know.
Well, where there used to be 30, now there's 16, 20. I mean, competitive? Well, they're all pretty goddamn competitive. Let's put it this way. If you qualify in Pro Stock, you're competitive. Because just qualifying is a feat.
Let's see here. And this is kind of interesting. So what parts of the Ford are Ford? Seems like clean sheet design. Exactly.
It is a clean sheet design. And
You're
so
right.
and so was the Coyote, and so was the God dang it. We got 2 of them in today.
Barra.
The new Ford.
Barra.
Huh?
The
No,
Barra.
no. I keep thinking Raptor, but that ain't it.
Oh,
Godzilla.
the Godzilla?
The Godzilla. Yeah,
Yeah.
all those engines are a clean sheet of paper. I mean, those engines, nothing on those engines resembles anything Ford has ever done before.
All right, Racer D, what's this one?
We can't sit here and stick with designs that came out of the 60s and expect to progress.
Right. Have you seen Pete Aradima Billets?
I have heard about it.
I
did hear about that thing. Yeah, the 2-piece deal. And I don't know if he talked to me about that or not, but somebody did.
238 miles an hour?
Yeah.
Wow.
You know, with rapid prototyping nowadays, with the engineering and technology we have, doing this stuff is 10 times easier. And probably, I would say, at least half the cost.
Wow.
And the end results are stunning. I mean, these engineers coming up nowadays, they live at that computer. I mean, that's all. It's amazing what the engineering, the techniques they use now that they didn't even use 10 years ago.
Just 3D printing is crazy when you see it done.
I mean, when they're printing in stainless steel, that's nuts.
Wow. Never even heard of it.
They're printing solid rocket engines now. The whole rocket engine is 3D printed.
Is it really?
Yeah. That is stainless.
Jesus. Got to have a lot of balls to get on that.
There's one company that's building a whole rocket. It's almost done. 3D printed rocket, the whole goddamn thing.
For what, satellite placement or for air travel? Wow. Check this out. This is a good one for you. What deck height is that and how many cam journals?
9 cam journals and a 9-inch deck.
9-inch. Okay.
Yep. I mean, this engine is only good for 400 to 500 cubic inches. That's it. It was designed for a normally aspirated 400, 500 cubic inch combination. And extreme engine speeds.
Everybody said happy birthday to my girl, so I'll tell them, guys, thank you for that. They look forward to seeing Darin and being on live. I don't know. They like it, I guess, but it's funny. Here's one. What's going on there, RevTech 426? Do you have any preferences between the Sunnin versus the Newen machines? And happy birthday. Thanks.
Are you referring to seat and guide machines?
I think he is, yeah.
My favorite machine still to this day is the 3100.
Tried and true.
And I mean, I use Rottlers every day there at BES. There are a lot of machines that are unworkable out there, and I'm not going to sit here and lay out which ones are bad and which one's good. But I'll just say that I prefer the 3100 or the contour machines. One of those two is the best. The rest are lagging behind. But who in the hell can afford a contour machine at $100,000? I mean, and you can achieve good results. It's not like you can't take a Rottler or a Sunnin or something and achieve good results with that. It just takes attention to detail and time. It's like when I do a cylinder head. As a matter of fact, I just welded one up the other day. I put all new seat rings in it. Now this thing, since I welded the whole combustion chamber, is going to move like crazy. So I'll do 3 valve jobs on that head. I'll do an initial valve job. I'll get my preliminary blending done, remove the material and let things move around, put it in the oven, take it to 250, flash cool the thing, go do another valve job, take it down and leave them about 5 high. And then the last valve job, you just touch it and get the concentricity to within less than 1/1000 and race it.
Dang, man.
If you just go do a valve job and then do all your grinding, that's going to move 1/1000 or 2.
Gurney for president. Thank you. That money I'm going to give to Izzy. Any money that I made on live chats, I always give Darin half of it. The rest goes in the DragBoss garage kitty to pay for the builds that we're doing. But this is her birthday. I'll make sure she gets that, Gurney, and I'll tell her it came from you. Thank you. What's up, Jenks? Let's see what this says. Do engine designers ever put cant on lifter bores, or is it that even possible?
No, it's not possible.
Okay.
I wish it was.
Yeah, this is what we were talking about earlier about the smaller mains. Been a discussion for 30 years.
Yeah.
I guess
I mean, it's not uncommon, or it was not uncommon at all to we actually made spacers and bolted them into the block and then line bored and line honed it to use a 427 main in the Pro Stocker.
Okay.
Early on. We always went to the smallest journal, and then the rod journals went, from 2 inch to 1/880.
Yep.
And then the Corvair is 1/770.
What's a 427? What's their mains?
Oh shit, I forget.
Okay. Let's see. Is this engine related to the one Jessel brought to PRI show a couple years back?
No, it's a completely different animal.
Let's see. Steve Cleveland, good evening, boys. I'm on a grader just checking in. Our Chevy fans are going to say that's close to a DRCE. Laugh out loud.
It is. Yeah.
There it is.
It's just better.
Anything?
It's just a lot better in so many ways.
Let's see. What's this? I would think that this program would be a great match with Charlie Westcott Jr.'s Pro Stock.
Yeah. I mean, he's put all his cards into the Hemi engines.
Let's see. I don't know about this one. He always has some good stuff that, just like a Ferrari going back to a 4-bearing crank in their F1 flat 12s, less frictional resistance.
Yeah. I mean, the friction power of any engine is something that, I concentrate on the heads, the airflow, the induction exhaust system, but the engine builder's primary job is to control the friction power. I mean, that's why we go to the thin rings and small skirts and thin bearings, and we do everything in our power to control the windage and reduce the surface area that piston has to ride on. The extremes we go to, people really don't have any concept of. They really don't.
Now, the cam bearings, you said there were 9 cam journals?
Yeah.
They're all roller bearing?
Yes.
70 millimeter.
Well, it comes 65.
Okay.
But it's capable of a 70.
Okay. I don't know. I don't really get this one. You'll have to answer this one. Do you like clamshell cams and short ratio long pivot length rockers?
No, I don't like either.
There you go. What is the P? You'll like this one.
No, wait a minute. Back up. Bring that question back up. I think I made a mistake.
Right.
Short ratio, long pivot length. Okay. I would rather have a short ratio and a long pivot length on an engine that operates at a high engine speed. But with the technology the valve train technology that Billy Godbolt does now, it's like I can't even keep up with it. I'm like 5-6 years behind, easy, because the stuff he was telling me on the phone just weeks ago was just blowing my mind. And before we would the engine builder would sit there and say, well, I want the lobe to have an intensity here and this acceleration ramp with this many degrees, and now he can go in and with his computer and with his software, he can literally dictate the motion anywhere in the system, and the cam will design the cam around that. So we're not chasing lift at max piston speed anymore like we were. Yep. A lot of the things that I used to do are no longer applicable. It's not the way that it's done. And this is why we specialize in everything we do. I mean, I do heads and intakes, and the engine builders are doing their thing, and the cam guys are doing their thing. And no one guy can do it all. It's just impossible. Absolutely impossible.
What is a peak RPM?
It's designed to turn right at 11.5. So with one carburetor, it's not going to get there. But with 2 carbs in like an A dragster class or in pro stock trim, in a dragster or an AED, if he got the RPMs up there, you would have to stall the converter at 9,400 RPM. That's where the converter would come on.
Yeah.
And then you'd have to shift at about 11.8.
So it falls back right down into the peak.
And it's plenty capable of that if you could feed it. But in an AED trim, no, you're not going to feed it up there.
And I think you talked about this, but it's easy to answer. Who cast these parts, Darin? Are the blocks CGI?
Yes, they are CGI. If I remember correctly, it was Cat Diesel who does all the CG work.
Wow.
They're unbelievable. And the way CG, it was explained to me, was CG is very hard to pour because they literally will keep it mixed and walk it over to the pour area and maintain a certain temperature. And if that temperature falls, they have to remelt and go back to square one. It's really fraught with problems. So when I asked for a deck thickness of 1 inch, they just laughed at me. So I think we ended up with about 745, 750 thick deck, which is thick. That's a thick deck. And I wanted that because of the distortion. In the DRCE 1s, 2s, with the DRCE bolt pattern, the distortion on the bore is readily evident. You go to like an MLS gasket, and it's a heck of a lot worse than the old wire gaskets. But still, everywhere you got a bolt, you're going to see distortion. And these bolts are actually moved away from the bore to minimize that. And then the threads go down deeper into the block away from where the ring is actually under pressure. So you minimize all that distortion on the top of the block. And with that thick deck, it doesn't distort almost at all compared to a lot of other blocks.
Bill, 2178, appreciate the $9.99. That'll go to the DragBoss garage for future builds. Thank you for that, Bill. Appreciate that. And we talked about this again. You can just reiterate it. The engine is optimized for 500 cubic inches. Does it have displacement and growth potential?
No, it is designed for one specific purpose, and that's 400 to 500 cubic inches. That's not to say you can't bolt a deck plate on the top and sleeve it.
That's right.
You know,
ask John Kazi about that.
Yeah. I mean, there's a couple of engines in the shop right now that are that way.
Really?
Mm-hmm.
Let's see. Here's one. Do pro stock engines use piston guided rods like NASCAR does?
Not that any of I have seen. None of ours did.
Okay.
I know it was tried, but I don't think anyone's using that. I don't know. I can't tell you. Maybe somebody might be, but I don't think so.
Darin Morgan, do you ever shorten push rods to optimize rocker to valve angles in relations to crank and rod angles? That's hard to answer. A lot there.
Well, basically what you're looking at in that block is doing just that by raising the cam and getting the lifters closer to the board, getting the deck down. You're trying to make the valve train as compact as you can. And yes, you want to try to make the valve train as compact as you possibly can. The shortest push rod you can get away with.
There you go. Love this deep dive into tech. Thanks, Scott. We enjoy it too. Any breather windows in the crankcase main journals?
No.
I've always said it's not just ring seal, it's oil aeration and pumping losses. There you go. Thank you, Bill. Appreciate it. I don't know if you talked about this. I can't remember. Main journal and rod journal sizes.
Well, let's put it this way. It comes raw, and you can machine it with any journal you want.
Okay.
And any cam bore you want. And size lifter you want. When these blocks come, they're not machined. So you have free reign. And the block is designed that way on purpose. Because of the different uses the engine will have, whether it's endurance or drag racing or what have you.
Mm-hmm.
So if you want to use a 2-inch main drill, you can do it. Oh, that wouldn't.
Let's see. Here's one here. What is the firing order? Is it used? What firing order is it using? Was there any reason behind selecting it 90-degree crankshaft or at 180?
Yeah, the standard 90-degree, the 180 crank is fraught with vibration problems, and even on the 90-degree cranks, a lot of times the cranks will be underbalanced a little bit, down into the 46% range, and the engine will actually shake until it hits its torque peak and clean up. And what you're doing is you're taking the throws and you're turning them down and making them smaller. So it takes less engines, it takes less power to accelerate the crank, and you have less windage because you don't have your, so you heavy metal everything and turn everything down as close to center as you can. And even underbalanced it just to get that last little bit. 180-degree cranks are not a good idea in a 90-degree. And the firing order is standard, well, whatever you want. Because
how you put it in, whatever
cam core you want, that's the firing order you can have.
I like this. This is funny. The 11 herbs and spices in this discussion are the next level. And then to hear it put in layman's terms, outstanding, Tim and Darin. Thanks. We thank you for listening. Now here's one that probably people have been wondering, and no one's asked it, but here, check this out. Is any of this available for sale?
Yes. It's in the Ford part. It's a Ford part number. It's in the Ford racing catalog. And if people order it, Ford said they will cast it.
Nice.
The only reason they stopped production is they didn't sell any.
They're talking more about carbon fiber rods. Not much we need to know about that. I'm not sure what this is. I think Comp AED for Tom Hamilton.
Not following there.
Nope, me either. Now, what was Neff's buddy, his partner that's working with him?
That's Harry Clack. He owns the car. He designed the car.
Okay. And that car was designed in a wind tunnel. People might not know that.
It was used using Formula One tech aero. And it is, well, let's just put it this way. In my personal opinion, that rail will revolutionize dragsters the way the rear engine dragster did.
Okay.
The aero package on that thing is probably worth 5 miles an hour.
Really?
Yeah.
I looked it
Shocking.
over. I'm like, wow, look at that.
It's shocking. He gained 47 miles an hour out the back half on that last run today. That's staggering. Staggering.
Thanks, Ramon. We appreciate it. Thank you. And then Bill, thank you again. We appreciate that. Jenks, it's good to see you here. Tell us what. Now, here's an interesting story. Now, you weren't there, Darin, but you probably heard it and know all about it. And it's a famous story that everyone likes to talk about. Tell us what Rear Morrison did to the deck of the big block Chevy heads back in the 80s when they de-stroked it using a 348 crank.
That's something you're going to have to ask David. I'm not privy to that.
There it is.
I wasn't there.
Yeah, that's what I said.
I was in junior high, man.
Yeah, I think I was too. Let's see. JMR. Oh, here's what we're talking about now. We're talking about the FE crank. Let's see what we got. The mains are 2.74. Rod is 2.43. Thruft faces, blah, blah, blah. If that helps, that's a 427 steel crank. So it's pretty much the same size as a Cleveland then, the mains. Let's see. Y'all ought to get Lake Speed Jr. on with what you use to discuss parasitic losses and friction related stuff.
Yeah, him and I, when we talk at PRI something, we can't shut each other up.
You know what? I've never met him, but I think I should do this. It'd be kind of fun to get him on here, us three on here, and get some talking about.
Just have him on.
All right. I'll hook you. You probably can hook me up with him, or I'll just call him myself. Let's see. Yeah, I don't know Steve Morris. I know he's an engine builder, I think. He's doing stuff with a Barra motor, that big Ford 6-cylinder in Australia.
That'd be a really good interview. Really good.
Here's something interesting. Darin, I remember watching a video years ago where they interviewed Warren Johnson about the DRCE when they were designing. Warren said the Shotgun Boss had the advantage because of the higher cam tunnel and bore spacing.
The original, well, if you're referring to the original 4840 bore space DRCEs, then
that's what I think he's talking about.
Yeah, yes. And that is a problem still to this day in truck pulling, because they don't dictate a bore. There's not a lot of funds to do really high-end engines in those classes.
Okay.
So they can't just dictate a 4900 bore space and everybody has to go out and get custom blocks. So you have the big block Chevy at 4840 and then Ford's at 4900. Well, the Fords have an advantage in a couple of ways. One, the bore spacing, they have a bigger bore.
Sure.
A bigger bore, you can put bigger valves in. Bigger valves move more air. You can raise the power potential way higher than the Chevy. So the fact that the Chevys are out there knocking on their door still is pretty impressive.
Nice.
I mean, you also have some drawbacks with the standard Ford. The valve train is really, really bad. It's hard to manage.
Now, here's an interesting thing. It's kind of going back to Cleveland's. I don't know if we want to keep talking about that, but he was talking about how would you fix the exhaust seat and iron 351 Cleveland head to create a Venturi when there's a 90-degree cut under the 45?
Ooh, ow, that hurts.
Yep.
Well, what you do is you bore it out, you put a seat ring in there, and then you backfill underneath of it with epoxy. And then cut your seat into the epoxy and blend right into the epoxy, and now you have your throat back. That's what I do.
There it is, one bad 50. He was talking about how the two-barrel head Cleveland heads don't flow worth a damn, but then he started switching the valve sizes and making them bigger, and that's what they needed, bigger valves. I remember him saying something. I don't know. Never messed with 2V heads. This is an interesting question. Speaking of casting, Darin, do you know if Ford was ahead of the time with thin wall casting, or was it just a cost-cutting move? Cost-cutting, I think.
By thin wall casting, I think what you're referring to is what's called like a lean production head. The lean production head started coming out with it like LT1 series before the newer LT1s, the old 80s LT1s. And it's a cost-cutting measure is all it is.
He's actually talking about the cylinder blocks, like the Cleveland.
Oh, the block.
The thin wall casting.
Well, yeah, it's a cost-cutting measure.
Yep.
And weight. I mean, weight's one factor too. There used to be a design limit, 120% or 200%. So when you design something, you design it to take 200% of whatever force you're designing that to take. So when they went to these thin wall castings and everything, that engineering standard came down. So now you have, like an LS, you can make 800 with an LS3, you can make 800 horsepower for the block starts to scream.
Okay.
And with a standard production small block Chevy, you could get twice that out of it almost.
Yeah, this is kind of interesting. I have a neat picture of Larry Morgan and Warren Johnson at the Caterpillar Foundry in Mapleton.
Yep, the Caterpillar Foundry are the cast iron experts in the world.
Are they really?
Guys, yeah.
Let's see. How about this one? Do you like high rocker ratios?
When I'm forced to use them, no, I still don't like them, because usually when I'm forced to use them, it's because I can't get enough cam lobe in the damn thing, and I've got to get some lift and valve speed into this thing to make some power. And like Pontiac with its small itty bitty core cams, you'll see guys throw 2-to-1 rockers. But nowadays, like I said, 5 to 10 years ago, I thought I knew something about valve train, but technology has just taken off. And the more I talked to Billy, you know, before we stayed away completely from 2-to-1 rockers. And he's like, oh no, we can use a 2-to-1 rocker. I'll just design the lobe to put the valve exactly where we need it. It's like, it can't be that easy. And he goes, well, it is now.
That guy must be a genius. You know, I've only heard him talk a few times and stuff. I don't know much about him.
I think he is.
I'll get him on the show. He'll come on and we'll talk.
Yeah.
Let's see. Here's one for you from Racer D. Darin, have you ever offset bore a smaller engine to move the bores away from the intake valve?
I have done that as well as offset dowel.
Cylinder heads. Yep.
Yeah.
Yep.
Move the bowl holes. Yeah. I've done it every way you could possibly conceive, including. Actually, we don't use stones. We use diamonds. And okay, this is a little nuanced here because everybody does it a little different. So I could tell you how BES does it, and somebody else will do it differently. And also, the honing technique isn't dictated by what stones you use. It's dictated by the metallurgy of the blocks and the rings that you're using. And, you know, if you get a new block, you check the hardness, you hone it, you run it, and then you see the wear, and you see how it's oiling, if it's oiling enough, and then you kind of you'll see it in the ring seal and the blow by and everything else. I mean, it'll tell you if you've done it correctly or not. But every block might take a little bit different hone depending on its metallurgical makeup. So saying just dictating a specific stone is overly simplifying the whole thing.
I mean, just with what I've heard about CGI, compact graphite iron, you have to have special, is that what it is? Special diamond tips to cut it because it's that hard.
You should.
Yeah.
You should use diamonds. And then, you know, some people will use a diamond and then a light stone or a brush stone over the top. Or there's so many different techniques that could be used.
It keeps me here too, Ramon. But the thing that I see and what I try to incorporate into this channel is not just about Cleveland's, but about pro stock from the past, the mid 70s, the early stuff, the Mopar stuff. You know, I'm trying to get it all together. It's just however it falls into place. This cutting edge stuff, I enjoy here. I'll never have one of these engines. I'll never even probably see one in real life. But I love to hear about what our technology is doing. Where has it gone? So that's why I kind of feature this kind of stuff. It's just amazing that you always think that there's nothing new coming out, you know?
Oh yeah, there is. It's because it's amazing. Like I said, everybody's gone their own little specialization and they just go to their separate corners, and pretty soon we all come out and say, look what we found, you know?
Is the airspeed limit in direct injection higher than it is in port injection or wet flow intake? Thank you for both being online. You're welcome.
A dry flow system does have a higher airspeed limit. Yes, it does. It most definitely does. And the port design and manifold design are completely different than a wet flow system.
Let's see, this might be interesting here. Looks like a GM block with the left bank being ahead of the right bank.
Yeah, we switched the banks because the cam, you can't get where we needed to get. Let's put it that way.
You're using to point out things. Yeah, we know we can't get a pointer. We'll have to figure that part out next time.
Also, you know, point of case when you're talking about dry flow systems, the design of the induction system relative to a wet flow system or a dry flow system. And at PRI, I'm trying to put together a round table, and it's going to be me and Preston and Matt Bieneman and Chad Spire and John Constantine from CD Cylinder Heads or CHI and Bob from All Pro and the guys from One Way Technologies. So we're talking some of the top headquarters in the world here. So we're all going to be together in one room. And the whole thing is I want to stipulate and show people how specialized these cylinder heads and manifolds and everything has gotten, because you can no longer just draw an overly simplified view of anything. Because these cylinder heads, you call up and you say, I want to operate this engine in this RPM for this reason, this many cubic inches at this engine speed, yada, yada, yada. We designed the cylinder heads to fit that engine combination perfectly now. It's not like it was before. So when you do that, now you have people taking these cylinder heads that were designed for one purpose and trying to use them for another. And there's other aspects of, I want these guys to talk about some of their new product lines, the rapid prototyping they use, the amount of time, the money, the effort, the investment that it took to bring that to fruition. And then we're going to talk about all the pitfalls now of these custom cylinder heads being out in the wild and these people grabbing them. And well, let's put it this way, that if you get a set of heads from a professional cylinder head guy, those things are, especially for a class in racing, those things are on kill. In other words, that guy has done every single thing he possibly can to optimize the efficiency in that area where that engine's going to operate. And then the customer will inevitably seem to take it somewhere else and get a valve job done. Okay, these ports are 90% efficient. Some of them are 92% efficient. One angle change, just one small angle change, and 5% is gone, and you'll never get it back. So that's another point of contention we're going to raise, that if you buy a set of heads from somebody, send it back to them.
That's what you told me. The stuff you've done for me, send it back to me. Don't send it.
I can't count. I mean, inevitably, it's 2 times a month. There are heads that have been valve jobbed incorrectly, and the 40 horsepower is gone. Happens all the time, constantly. The wrong valve job, 40 horse, boom, gone. You'll never get it back, no matter what you do. And you'll wonder why you slowed down a mile an hour in 500s, 600s, or 800s, and why the engine's lazy. And just that one change did it. Because this stuff is finite. I mean, it is so fine-tuned anymore.
I sent Matt Beineman a copy of this link for the live chat, and like about probably 5 minutes later, he texted me back, and because we've been talking, and he wants to be on the DragBoss Garage, but he is so busy. He's, he runs the whole show. He's got people there working, but he has to manage and all that stuff, not let alone design. So he told me, he said, listen, don't give up on me. I'm going to make it. I'll be there. And I want to talk about his new Ford head that he's got coming out, and just to get a different perspective of how he looks at things when we compare it the way you look at it, because you do the same thing, but way different. And it's kind of cool to bring it all together. So,
you can look at modern high-end cylinder heads today as being booby trapped.
Oh yeah.
Because the way Matt does it is a little different than the way I do it.
Sure.
And the way Chad does it's a little different. And the way other people is a little different. So I can't take what he has done and turn it into what I do. Because the wall angles are a little different. Things are different. He uses different angles. He leads into the back wall different than I do. But the end result is the same. But the subtle interpretation of looking at that port and say, well, I could just cut it with this valve angle and, get it to seal up. Well, those throats and everything are tuned to where, like I said, one small change and boom, it's gone. Power's gone. Okay, next question.
I'll answer this. This is for Yanks, at least in my opinion, and then you can throw it in there. This is like old school pro stock stuff. But just to tell you, from what I've researched on pro stocks from the Cleveland pro stock era, we're talking 70, to whatever it was, 81, we'll say. Okay, they had to be making roughly anywhere from 7.25 to probably 840 in that range. Bob Glynn was probably in the 800s. Because for his car, his best Fairmont run was an 828 at like 165 or something, some change. And for that car to go that fast, it had to be up in the 800 horsepower range, 840, somewhere around there, for it to run that mile an hour with that weight. So that's kind of where you're at. That's what I would say. What would you say? Darin, anything to add to that?
No, that's about what they were.
Okay.
And that little bit,
that's why he made 840 is because he was, changing valve angles, because he was changing, angle milling. He was doing all this crazy stuff. So, like you said, the little things that make it. I've never heard this either, but that's interesting. Has anyone tried chrome bores like they use on two-stroke engines?
Yes, Nicosia liners are a thing. And as a matter of fact, Clint Neff's 4-cylinder, his billet aluminum block is Nicosia lined. It doesn't have cast iron bores. It's chrome.
So what do you run for rings in that? What kind of material?
Yeah, you have to have special rings.
Yeah.
Yeah.
Not
just any ring package will work in that.
I don't know we'll put this on here. Where do you want the minimum cross section in an intake port or manifold, or a specific distance from the valve? That's tough, I bet.
The absolute smallest cross-sectional area should be at the throat, right at 250 to 300 thousandths underneath that valve. That should be the smallest area, because when the cylinder pressure drops, the airspeed is at the throat. And just like weather, everything moves from high pressure to low pressure. So that throat down there is what dictates the velocity increase. The pressure drop right there at that throat moves all the air from atmosphere to the valve. If you don't have that high velocity area, if your throats are too big, the engine is lazy. It can't accelerate the air. And if you can't accelerate the air, you can't trade that airspeed for inertia and fill the cylinder while it's closing, which is what we're doing.
So it's kind of like the limiting factor.
The throat is what controls more than 50% of what I do. I mean, 1 inch above the seat and 1 inch below the seat controls about 50% of the game.
Okay.
Everything else is just accelerating or turning the air around the short side.
Let's see. Greatest for...
The closer you get to the valve, the more critical everything becomes. Let's put it that way.
Hey, now this is somebody I haven't heard from. Argentina.
Hey.
Julian Sanchez, good to see you. And this is what he was asking. The Venturi window is really good. Not sure what you mean, but I kind of get what you're saying.
Yeah, I'm not following.
Maybe there's another question. Let's see. Now here's a guy. He does his own porting. He's got his own YouTube channel, Terry Grover. He does a lot of big block Ford stuff. Thank you.
You're welcome.
Appreciate it. Now, what's this question for me? Question for Tim. Have you ever had any experience or know anything about Titus aftermarket blocks? I'll pass on that. Thanks. Never had any experience with them. Let's see. Man, there's a lot of... well, Dean Stevenson, he always asks a lot of questions. New Zealand. So we have a lot of people from all over. Great that. Are CHA heads out of the box here? Out.
Well, again, it depends on your application. It depends on what you're using the engine for.
Yep.
If you want to know what the best head is, you call the shop, call BES, tell them your combination, what you're going to use it for, what your intended RPM range is, and they'll pick the head for you that should be fit that combination perfectly.
Now, a big shout out to Chad Carpenter. Now, he talked to, let's see, Justin probably last week, and he's bringing a Cleveland down to have done there from my engine being there, and you're going to do the heads on it. So he's pretty excited to be working with you guys.
That's what I like about working with BES. I get to work on everything.
Different stuff. You never know
everything
there.
From Briggs and Strattons to Bugattis and Alfa Romeo to whatever. It doesn't matter what comes to the door.
I don't know about this question. Can you make a Ford FE cylinder head and intake combo that uses modern technology so that the intake doesn't overlap the valve covers and push rods and go through the intake?
Considering the structure of the block, that would be quite difficult.
Yeah.
I would say no. Now, you have to realize that the Ford FE was on the drawing in 1938 is when they started drawing that engine up. That is an old engine.
1938?
Yeah, and it didn't go into production until 55.
Yeah.
So, because of the war, basically.
Now, here's a good one for you. What advantage does this oil pan / individual piston / rod chamber design offer? which we kind of talked about, didn't we? About
If
oil
you
knocking on the can.
if you use a segmented pan, you can control the oil windage a lot better. That's why.
What bell housing is on your JC51 block?
Oh shit! You would ask me that, wouldn't you? I forgot.
Well, it's got to be. He's probably running a 400 tranny in that thing.
I'd have to. Yeah.
So,
Yeah.
But they make adapters for everything, so I don't know. Good question. We'll find out. Michael,
I think it is a Chevy. It's a Chevy bell housing.
Okay. Let's see, Victor. People are answering questions. Let's get rid of this person. Find my sexy photo here. Okay, bye. We had a bunch of people like coming in here. One guy, they would get into this studio and like try to butt in. Somehow they figured out how to get in there. I changed a bunch of stuff around. So now here's a good one. I don't know about this, but I know Tony was talking about this, Tony Bischoff.
Is that a question?
I don't know. I think it's just a comment. I don't know anything that he has there making that horsepower, does he?
Let's put it this way. I couldn't talk about it even if I did know.
There it is. Lips are sealed, baby. Chevy bell housing is what the person said. And then they all put, we'll never hear the end of it. There's like a big Ford versus Chevy. You know that rivalry that's been going on for, 150 years. I don't get into drama. I don't have time for that stuff. So I let people say what they want, and then I'll just stop it after a while. But I really, it blows me away that you're taking the time to educate us on this, Darin. Thank you for that. People on here are not ever going to see this or even know where it came from or how it got there without this discussion.
Well, this was supposed to be kind of, well, I thought it was going to kind of be my greatest accomplishment, but it ended up falling short, and I just got depressed and didn't even want to think about it. And then 8 years later, Neff says we're going to build one, and I got all hyped up again. What sucked is you put all that effort into something, and then nobody wants to use it. And it's like, I'm sitting here, I'm thinking, I didn't know it was going to do what it's going to do, but I damn well thought it would.
Yeah.
Or we wouldn't have done it that way.
Look how long it's been to prove your point. Look how many years it's been.
It takes a long time. It really does. It takes 10 years for like a head to catch on or an engine. It's I don't know why, but there's cylinder heads that I designed 13, 14 years ago that are just now people are starting to use them in the last 2-3 years.
And I was telling you about Chad Carpenter just now. He's got an engine coming down there. He said, "Hello, Tim. Nice to see Darin back on. Does BS sell Blue Thunder heads that will work with a Wyand tunnel ram for Cleveland 393? Or other heads are good to use other than Iron 4V?" So
whether they do or not, that's not the part of the business I handle at all.
Yep.
I'm back in the back working on heads. So
and I can tell you they don't have Blue Thunder heads. Nobody has them, Chad.
Yeah, finding those, I do know that finding them is going to be about impossible right now.
Yep.
As a matter of fact, the production, getting parts is
it bad?
People have got to be patient. Everybody has to really, really be patient for the next 5 years. Because instead of an engine build, I mean, just like the Ford, this thing, this thing took 5 years of effort to get everything together. And, you bring an engine in, and before it would be 6 months, and now it's going to be a year. It's just twice as long. Twice as long.
You might
and also now I want to say something too.
Yeah.
Something that's part of the problem with getting parts. I'm going to be ostracized for this. I know I am.
No one listens to DBG anyway, so don't worry.
These venture capitalists have bought out all these racing companies.
I know.
And what happens is they kill all the R&D, darts R&D, all the R&D that was done to get to like where we are here with this Ford is now dead. And then they kill all the projects for the racers that aren't profitable. And now that just kills and now it takes 5 times longer to get anything done, 10 times longer. So that has really hurt the industry badly.
I'll tell you, I don't know about being ostracized, but the way I look at it, it's pretty simple. The bottom line is, I think in reality, they're trying to get rid of high performance in racing. They're trying to.
That's exactly what I think.
They're just trying to kill it off, and that's what it's happening.
Well, if you buy up all the companies and run them into the ground, what's going to happen?
And that's what what do you call them? Venture capitalists. They're buying up, let's say they buy Holly, and then they buy, I don't know, Jessel and T&D, and then they conglomerate them, and then they cut.
I mean, racing is not a profitable business. We do this because we love it.
Right.
Not because we want to make money at it, for God's sake.
No.
I could do 100 other things and actually make 3 times the money I make. But when these venture capitalists come in and they buy the companies, they strip them, they make them look good, they get them profitable, and they either resell them or what have you.
Take them apart, piece them up.
Yeah.
Let's see. Darin, on the Cleveland, the firing order means that cylinders 2, 5, and 6 hit the front half of the manifold consecutively. How does that affect distribution and fuel flow in a wet manifold?
Well, yeah, with any firing order, you're going to have clusters. It's like that. Okay. Whether it's, 5 and 7 on a Chevy or a 2, 5, you're going to have that issue. There's no firing order that corrects that issue. So whatever manifold, you're either going to have it in the front or the back, depending on what you do with firing order and cam cores and what have you. Is it better to have it in the front than the back? No. It's just one of those things, that you have to overcome and work around, because it's not something you're going to fix.
Now, is it something like staggered jetting, like the big black Chevy needs or works better with a staggered
jetting works sometimes, but you have to be careful with that. You can really start to chase your tail with that. Okay. Because if, let's say you have 2 carburetors and you stagger one jet. So what you've done is you've increased the draw on that bore. So it changes the hydrodynamic pressure in the main well and at the throat, and affects all the other bores along with it. So if you're pulling harder on that bore trying to pull more fuel, you can't, because it's equalized.
Because of the jet circumference, the area of the jet you're talking about.
Yeah, and the pressure in the float bowl, the hydrodynamic pressure, as well as those barrels are going to equalize. So if you try to make it easier to pull fuel in that one, you're still going to have the others trying to compensate for that out of balance situation. Okay. Air bleeding is another way to do that. But yeah, in some cases, it's mandatory. It's a necessity. You have to do it, but you can really get into trouble and chase your tail if you're not careful. And just like ignition timing, you can, with individual cylinder timing, you can chase your tail around and around and around and just drive yourself crazy, because because if you affect one cylinder, it affects all the others.
Okay. Do Cleveland suffer from that like a big black Chevy because of their port layout being symmetrical versus asymmetrical? Or not as much?
Well, the Chevy suffers worse because it's asymmetrical. The runners are right together.
Yep.
Because a symmetrical head has what we call runner isolation. The opening in the runner and the manifold is isolated from the other and the walls itself. Yep. A lot easier when you have a symmetrical port layout like that.
When they're asymmetrical like the big black Chevy, does that width between the 2 ports, does it pull on each other even though there's a gasket in there? Is there some kind of velocity between the 2 runners and the airflow? Or
not enough to make a difference.
Okay. And I told you this before when we talked earlier, when initially we were going to set this up. Darin, let me tell you something. You got to be damn proud of this project, which I think I said, wish I had a thimble full of your talent.
Well,
thanks.
I've never in my life got everything I wanted in a project like this. So I'm still kind of pinching myself, actually, to tell you the truth. With what this thing is actually doing, it's kind of stunning, and don't think me. I mean, think Jim Cunningham and Sweeney and Mose Nolan and everybody at Ford, because everybody put their 2 cents in this thing, and we all got what we wanted. And guess what? Because usually what happens is you'll go in and the engineers we'll say, nah, we're not going to do it that way. And there ain't a damn thing you can do about it, which is what you get like a DRC E3.
Sure. And this kind of goes back to what we were talking about 2 minutes ago about taking time to get parts and stuff. Off topic, but it's relevant to racing world, Darin. Have you heard about aluminum shortage and high grades of steel alloys?
Oh yeah, it's hurting us on rods and everything else. Rods especially.
But if you want to set a billet rods, how long does it take you to get them custom, you know?
Well, let's put it this way. If it took a week, it's going to take 5 to 6 now, maybe 8.
So 5 times as long for any parts, basically.
Yeah. We just got to be patient.
I don't know if this is, I mean, I'll put it up there. We don't have to draw on it if you don't feel like talking about it, because it kind of relates to what we were just saying. I recall when the deal fell through, you were seriously pissed. What really happened? Who killed the deal?
Well,
thanks, Chuck.
Nobody really killed the deal. It was more that Jim Cunningham passed away.
Okay.
And that whole team kind of disbanded. If that wouldn't have happened, yeah, we would have had one in a pro car. There have been people trying to, but there's no money in pro stock. There's no sponsorship. There's no factory backing anymore. So getting one of these things up and running, I mean, it takes a serious amount of effort and money to do it.
It's like I've said to people before, you know, I stopped watching NASCAR and really pro stock racing somewhere probably around 2003 or 4. I got tired of seeing the same cars. Just everything's the same. You know, they're all running the same stuff. You see something like this, it might peak things. Things might change.
I don't think so, because
availability.
Do what? Well, no.
Okay.
It's just the way racing's going right now. I don't know. It's kind of up in the air.
Let's see. Darin, have you ever had to modify intake manifold runners to tune each cylinder on a carb application?
Oh, yes. Yeah.
As far as like, are you talking about port volume or location or?
Well, let's say you had fuel runoff issues on the floor or something. You could accent that. If you have 2 of them firing it together, you can try to isolate one runner or increase the airspeed, put less taper in one runner to up its airspeed to try to counteract the other. You can do, there's a multitude of different ways to manipulate individual runners to try to even out a manifold.
If it's falling out of suspension, you want to increase the velocity, right?
Velocity is always the best Band-Aid to try to utilize to fix stuff.
Okay.
Because it's usually the one thing that's wrong.
Okay. I can tell you, you answer this and I'll answer what I've heard.
Okay. To design a head, have it cast, and the first 40 castings, you're looking, depending on what it is, between 80 and 100,000.
I think that's low, but just from experience from talking to somebody that does it, Todd Buttermore, just for an intake manifold alone, 40 grand.
Well, yeah, manifolds alone are 40 grand. That's true.
Just a pattern and getting it ready to pour one.
And that's why you don't see many manifolds, because the profit margin on a manifold is about $100.
I mean, it seems like it when you look at the numbers.
200 max. So how many manifolds do you have to sell to recoup your R&D cost?
200,000.
Oh yeah, thousands.
So,
but here's the but. Now we have rapid prototyping 3D printed cores. So we can make any cast manifold for about $6,500. Anything you want. You can design it in the computer, print out the 3D cores, cast it, boom, it's yours.
I can't believe you can 3D print metals.
Oh, they 3D print the actual core box that they pour the metal into.
Jesus. No, but I mean metal. They could 3D stainless. You were talking about, or something.
We used BES. Tony and Preston have designed multiple 3D manifolds.
Really?
He's probably got a line of at least 4 or 5.
What are the like Ford? I only use Ford because that's the only one I know. But LS probably has them too. They make like a phenolic intake. It's plastic. How does that relate to the carbon fiber we talked about?
Plastic manifolds. I have never yet seen a plastic manifold make as much horsepower as an aluminum manifold.
Okay.
For
Here's a good point, and this is a good point to bring up because we've only been talking about NA. Read this and see if it makes sense. The truth being told, people have gotten lazy and all they do is boost everything and then act like they're the hero and they make 1,000 horsepower. So true. People have gotten lazy. They don't know how to take the fine details and make that horsepower.
I didn't say that. You did.
Yeah. You know what? And I'll say this, there's only 235 people here watching this. But in reality, people have become more lazy than I see when I look back to where I grew up as a kid and what I see the new generations are.
We have power on tap nowadays. Technology is so advanced. I mean, 1,000 horsepower in a street car, not a problem.
I know.
Not a problem.
It comes down to this. You got the green, you get the green, you know?
And being lazy, you know, I'll say Ferrari said it best when turbos were allowed in Formula One. He says, "Oh, great. Now idiots can build racing engines."
He said that?
Yeah, he said that. Now, let me preface, let me say this about that statement. Anybody can bolt a turbo on an engine and make power. But guys like Duttweiler and other people who specialize in that know how to build NA power too. And when you have a guy who can build NA power and you give him a turbo, he's a deadly son of a bitch.
Damn. I like it. In fact, you told me, I called Kenny Duttweiler. I called him a couple of weeks ago, but then I never got a call back. So I got to remember to put him down on the list. I'll do it right now. We were talking about him. I don't want to forget. I have to have a whiteboard to write down.
You know, power is relative too. I mean, you could bolt a turbo or a supercharger and make 600 horsepower so easy it's not even funny. And put a smaller pulley on there and injectors and make 700. It's just too easy anymore. And you know what? That's great. That, you know, power is power. I mean, if you make it cheaper, make it cheaper. And that is what has killed NA racing, is the availability of cheap power, and a lot of it.
Because I got to agree with this. Go ahead. Sorry.
To develop one of these engines in a pro stock trim is going to cost, you know, 150 grand. Plus, you're going to take months to tune the thing and work on it. And, well, you never stop working on it. So you've got hundreds and hundreds of thousands of dollars to develop these things and keep developing them year after year after year to try to gain that 5 to 10 horsepower a year that, you know, you're always working for. And I added it up back in the 90s. It was costing us about $35,000 a horsepower, and for our R&D cost. And then by 2007, it was like 80,000.
Now then, it must be even lower though if they have all the new technology.
Do what?
It must be lower now with the new technology, correct?
It is, but you still have the labor cost of the team
yeah.
beating on them damn things all day. And
let's see. Someone said the electric power is never going to be around or something. There it is.
Diesel engine will remain for the next 150 years. The auto cycle gasoline engine, however, I'm afraid they are going to phase those out over the next 50.
I said that racing's going to be done in the next 10 years. I said it to myself. That's what it makes
me I said that 10 years ago. I'll probably give it another 25.
Okay.
Well, yeah.
I'd like to be retired.
We'll always have custom shit. You know what I mean?
Oh, yeah.
With the rapid prototyping technology, we can always do our own engines, and we can keep it alive. But we'll never see it like in the heyday. I don't think so.
Here's another one. Let me see if I can pick this up. When it comes to mixture motion, does most of it come from the flow through the valve into the cylinder / piston motion, or is the head a much larger part of it?
It's basically all in the cylinder head and the way you aim the runner and the combustion chamber shape.
Okay.
So on an unlimited NA engine like the Ford, we get all the mixture motion we need through the sheer velocity and amount of air going into the cylinder. So when you have a low engine, an engine that operates at cruising at 1,500, 2,000 RPM, there's no airspeed for mixture motion. So what they do is they design the ports with high angles of attack into the combustion chamber, and the combustion chambers are skewed in such a way as to accent that mixture motion. So what you're doing is you're trading airflow for mixture motion. And in low speed engines that have to operate at with emissions and create good torque down low, like the Vortec head is a perfect example. The small block Chevy Vortec head with its offset port. That's a high axial swirl port. It doesn't flow any air. Well, it doesn't need to because it doesn't see the high side of 4,000 RPM on the power band.
Okay.
It's meant to hang at 2,500, 3,000. And that's where mixture motion belongs. That's where the study of it belongs. And that's where the application of it belongs, not in a racing engine.
Economy.
Yes.
Efficiency.
As a matter of fact, a Hemi has no swirl. And neither does a DRC E3. Or this Ford has very little until it hits
port layout.
Until it hits 800,000s, that there's almost none. The angular velocity is almost straight down the bore at about a 45-degree angle. Until it really opens up, does it even start to turn?
But it still has to hit the short turn. It still has to be guided in. Yeah.
And you design the ports to incite and to instill that motion. It's in the port design in the chamber.
Darin, in today's pro stock, are efforts made to eliminate crosstalk in the intakes or plenums still seems sort of conventional?
Yeah, I've only built 2 of those things, and the front mounted throttle body is difficult to manage.
Okay.
It pressurizes in different places down the racetrack. It pressurizes the manifold front to back in different ways. And that's something that, but with EFI, they can counteract that. And I'm not privy to any of the tuning that they do on that. I haven't seen any in years. But the manifolds themselves, I mean, they've dictated the injector location. So there's not much you can do about that. One of the ones that I built, the runner's here. So you put the injector like this, shooting down the runner.
Sure.
So what I did is the injector location is marked. So I pointed it back into the plenum. Now that made more power, but it was untunable up high. When down track, when it pressurized the back, it completely screwed up the air fuel mixture and all the other runners. So dynamics on the racetrack dictate manifold design more than anything on the dyno.
They always say you don't race the dyno. You know what I mean? There's so much difference in dynamics.
I mean, even carburetors, when we were running carburetors, you had your dyno carburetors and you had your track carburetors, and you don't mix them up because the track carburetor is going to make 25 less on the dyno.
Now that's a good statement right there for people to listen.
Because the air bleeding's changed, everything's changed.
Darin, would titanium connected rods work with this combination or aluminum better?
Titanium rods will work. That's fine. There's a lot of problems. Well, let's put it this way. You have to keep on top of titanium rods.
So many runs and they're done.
Well, you have to change the bolt. Every time you rebuild the engine, you have to put new bolts in.
Okay.
New coated bolts. And the torque sequence is, the way they're torqued is very specific because you can gull the threads. Titanium is not a metal that's not compatible with any other metal. So it gulls and it does all sorts of nasty stuff. And its modulus elasticity is very high, meaning it's like a rubber band. The main cap can give a lot.
Okay.
So in many instances, I've seen, instead of having a round bore, you'll actually machine it oval at the parting line. So at RPM, it comes back around because they move so much. And after time, they'll work hard and they'll also bring that in too. If you just have it perfectly round, some of them will actually try to bite. And it depends on the manufacturer and how they design them. But they're kind of fickle to work with. Aluminum's easy. Aluminum's simple. I mean, you can throw some aluminum rods in there and spin it 11,000 and change them out every 50 runs and you're fine.
Nice. Now, we hadn't really talked about it, but we talked about early when we first started, and I mentioned it before, that this 500 cubic inches is going to make 1,500 and that's it. It ain't going to make no more than that. So people were asking about, well, the volumetric efficiency. Well, you can get 110, you can get 120, 115. How do you get 130? How do you?
Well, actually attaining an actual 130 is the physical limit. I mean, we only have so much atmospheric pressure, which that differential basically dictates that limit.
Okay.
So if you can only get 130% VE, 3 horsepower, about 3 horsepower per cubic inch is that's about it.
Okay.
Unless in a push rod V8, that's probably about the physical limit. Could we probably get a little more in 20 years? Yeah, might, but I don't think so. And the 1.65 foot-pounds per cubic inch correlates with 124% VE trapped, which is about what they run at. Seems like that's calculated. It's not measured.
This one's got to be for you because I'm not getting it. Let's see. One place making cylinder heads for an inline 6 that has a 2-valve and 4V version. Deshroud the 4V, but do not deshroud the 2V. Any thoughts on why they would do this? Same short block.
I would have to know the application we're discussing, and I'd have to see the pictures of the cylinder heads.
Okay.
And if I were you, I'd just call him and ask him why you're doing that. And that goes back to the designing heads for specific purposes again.
Now, I think this guy's talking about Carl Foltz, which I don't really know him. Why is Foltz doing differently than others to get contracts he gets? Is it ECA? I have no idea what that means.
I have no idea.
I think because there's conversations going on the side. I don't think you can read the comments like I can. So it's hard to go through them and figure out what are questions and what is just talking back and forth. Now here's another. He asked this question before, and I don't know this, but you might know. Is this motor like the stuff Ed Lyons cleaned out from Ford Racing when he left and put in a comp eliminator rail with his son?
No.
Okay.
I think you're talking about the old the J. Yeah, I think that is the cylinder head that Ford originally wanted us to use in Pro Stock.
Okay.
And it's more of a high rotated deal. And we weren't able to utilize that in Pro Stock trim.
This is just what we were talking about. Take away the power adders, and a lot of people are lost in space.
Well, power is easy. And when you make things easy, you don't have to learn how it works.
Let me see. If you could repair a block with furnace brazing, would the heat hurt the block at all? Well, yeah. Takes away the heat treating. Mm-hmm. All the surfaces have to be remachined, everything.
Well, it depends on the temperature and the time at temperature.
Oh, okay.
But yeah, you will soften that block. It'll go down in hardness depending on the time at temperature. And my brother actually utilized that one time. We had a block that was too hard, and no matter how we honed it, we couldn't keep the ring seal. And he put it in the oven at 575 degrees for 2 days and brought it down about 20 points, and it was usable.
Now, this is who, your brother?
Yeah.
I have a Cleveland block, and I'll make a video of it. It's been sitting here, but I got it from a guy in Montana. He sent me a Cleveland block with a set of those heads, the high port heads with a fin in it. So this block, I think it's furnace brazed. I don't know. I'll take a video, but all the cylinders are welded. You can see them. It's all welded around the whole bottom of the thing. I've never seen welding like this. I'll take a video and show you.
That is a lost art. It's almost impossible to find guys that can do that now.
This was done back in the 90s, I think, and he said it cost $2,000 just to do this, put the sleeves in it.
The last set of heads, and these heads actually hold the world record in some super stock classes.
Yep.
Or a set of Windsor cylinder heads, and that are actually cast iron welded to combustion chambers.
Okay.
And that was like $2,000 per head.
Wow.
But you can't tell the difference between the original cast iron and the welding. That's how good it was.
You can't see the demarcation line where it's...
Most of the old guys that know how to do that are retired or gone. I mean, cast iron welding is a lost art.
Here's one for you. Man, I'd love to be a fly on the wall for the conversations between Darin and Lake. I don't know what head this is. L31?
The L3 one?
Is that supposed to be LS3 maybe? I don't know what it is. Let's see. I'm telling you, we got 247 people on here. We've been here for a little over 2 hours. I was talking to Darin before, and I said, listen, we can't be going 3 hours. It's just, that's a long time. And we'll try to.
It does anyway.
We're still going. Here's what. Let us talk about cars in Australia, which I don't think you follow with that or anything like that.
The Australian Pro Stock guys, I do.
Now they're all small block, right?
400 cubes.
Yeah, and they're
instead
pretty
of 500.
scary.
I mean, those engines are making 1,200 horsepower.
Let's see. LS, where has 2-valve naturally aspirated cylinder head tech evolved to currently? Valve angles, chamber shape.
Oh boy,
I don't know.
That is impossible to answer because, again, depends on what type of engine you're dealing with. So as far as NA cylinder head tech has evolved to the point where we could now design a cylinder head and manifolding specific for your combination better than we ever have before. I mean, we know the recipe. We know what to do in each instance. So being able to actually do individual cylinder heads for individual combinations is where it's at.
Darin, did you ever use a tumble fixture on the flow bench to design or port on these heads?
Yeah, I had a swirl twirl tumble torque swirl that measured the torque swirl, and then I just had a paddle, and I accumulated that over 10 years, and none of it correlated with power at all on an unlimited engine.
And here's a couple what we were
The
talking
velocity of the air entering the combustion chamber is plenty. I mean, we have small chambers, lots of quench area. We have mixture motion. We don't have to worry about that.
Let's see. Darin, do you ever think a 4-valve engine will get close to 1.65 pound?
Not until they get the valve speed up.
Valve speed?
No rocker, no valve speed, no torque.
Okay. All right. Yeah, I can see the cam just sitting on top of it. So yeah, that makes sense to me.
And they have a lot of area. So you're feeding the engine a lot of area real quick, which is like having too big of a cam in the engine. Of course, you can cam 4 valves. I mean, Kazi has proved that you can make some pretty god-awful power with a 4-valve, but it takes an extraordinary effort.
And money.
Yeah.
I don't know this one here. The 400 cube Romeo by Kazi does 1.65 feet per cube DOHC modular before it was banned from Engine Masters.
Yeah. Like I said, Kazi, I think, has got more torque per cube out of those four cylinder or 4-valve things that I've ever seen.
Let's see here. Darin, out of all the manufacturer's engines, faults, and good design, which engine has the least issues and easiest to gain power on?
Oh, boy, that's a loaded question.
I know.
Easiest to gain power. Well, the LS series, I would imagine.
Okay. Which I don't even know. I don't know. LS3, LS4, 5, 6, 7. I don't even know how many there are.
I mean, the LS engine is I mean, you can make some god awful power with the LS7 engines. Easily. That's one of those things that power has become so easy. I mean, NA, you can make 650 with it in a street car on pump gas. I mean, that's nuts. I mean, you have to really cam it up and wind it up, but yeah, it's there. I mean, supercharged, you can make 800 to 1,000 with them. So yeah, that's probably the easiest I can think of.
Let's see. I talked to Preston. He said that he could do a welded raised runner on a twisted wedge R and make 400 CFM at 800 lift. You do it?
We can do just about anything your little mind can dream up.
I like your channel. He's got a good channel I like to watch. Let's see. Now I think I've heard of this guy. Alan Manthan was the cast iron welding master.
Was?
Yeah, must be RIP'd.
Yeah,
like you said, not a lot of guys.
Everyone that ever did work with me is gone. I mean, I can't find anybody to do it. I mean, it is an art to do that properly. I mean, to bring it up in temperature and to be able to weld it and then bring it down in temperature without instilling stress and cracking an iron head. That's, yeah.
That guy, his name is Sherman Sly. He made the first Cleveland 6-cylinder head. He told me he welded, what did he say? 12 hours. He welded nonstop. Had to heat it up to 1800 degrees, worked on it 12 hours nonstop, didn't take any breaks, welded and welded. Then he had to cool it off in borax for like 24 hours or some kind of long cooling process.
See, that's the thing. Once you get the heat in it, you can't stop.
Yeah, that's what he said. You can't stop. He drank 12 Pepsis or something and kept working. Let's see. Darin, when filling a block halfway, is the structural steel no shrink Portland cement the same stuff as hard block?
Okay. Look up, just Google Embico 885, and it has changed names, and I forgot the new name for it. But Embico 885 is a metallic grout.
Yep.
That is what hard block is. And you can buy a 55-gallon bag for what you can buy 5 gallons for of hard block. It's the same stuff. It's a metallic grout. It has, and basically metallic grouts, and this is kind of a funny story. When my father, Kip Martin, back in 1980 started filling blocks, he was looking for something to use, and he went to an engineer who worked with cement metallic grouts and stuff like that, and he says, well, there is this one stuff that was designed for the Saturn V launch pad to hold the steel beams. So when the steel beams got hot, the coefficient expansion of the actual cement or grout would be about the same and it wouldn't blow out. And that is what Embico is. And it has almost the same coefficient expansion and contraction as iron. So it doesn't pull away or cause stress.
Okay.
And it's perfect. But the trick is to mix it really thick and don't vibrate the block. Don't let the metallic portion, it's got actual iron shavings in it. And the trick is to pour it really, really thick as you possibly can, and don't wrap on the block too much to settle those shavings out. And it's about bulletproof. It really is.
Someone commented on one of my posts today and said that a Cleveland block that's not filled, the bores move 9,000ths of an inch at 2,000 RPM. He said if you fill it to the bottom of the water pump holes, you pick up 50 foot-pounds of torque. I don't know.
I have seen guys run half-fill blocks on the street many, many times. You just got to add another oil cooler.
Yep. I'm not sure what this one is. Cast iron welding in a furnace using pure cast iron rod was what I was talking about. In the Glidden episode a while back, machine surfaces were pretty much invisible.
Huh.
Yeah, the only thing I know that they used to do furnace brazing was like Bill Kuhn was one of the guys that did them in Michigan back in the day.
Well, what about Richard Maskin and Canters taking 2-cylinder heads, sawing them in half, taking an inch and welding it in the middle?
I have a set of picture of those. That'll be on one of my pro stock ones.
That was the first pro stock head.
Yeah.
And Maskin and Canters were the first ones to ever build a sheet metal manifold.
Yep, I remember you told me that. And Glidden was running a sheet metal manifold in 81. I can tell 80, the end of 80 and 81. You can see it in pictures I have. Now, whether he made it, I don't know where it came from, but let's see. Darin, the CID Ford SC2, how do you adapt it to the LS because it looks like the same casting, or you just machine them different to fit the LS?
Yeah, I have done, oh God, I've probably done 4 or 5 sets of those in the last 5 months.
So you're putting the SC2 on an LS block.
Yep.
Okay.
It's called the the CID LS too. Basically what we have to do is I make a custom plate and I bolt it to the front because the China rail is shorter and the head is longer. So that handles that. And the Ford bolt pattern and the LS bolt pattern are really close. So that's not an issue.
I mean, what are you saying close? Are you talking thousandths of an inch difference?
Yeah, 50 thousandths here, 80 thousandths here. It's not
Okay.
a big deal. It's still within the bolt bosses of that CID casting. So yeah, it was not difficult to adapt that to an LS. I mean, you're talking about a head that can move 500 CFM on a small block. That's nuts.
That's how much they flow?
480 to 5, yeah, depending on the valve size. And
it's crazy.
I mean, 480 would be the small head.
I know we talked about this when you were doing this before, but I don't know if you ever finished with any of this.
Yeah. I built a sheet metal manifold.
Yep.
Was in the process of doing that. We have 2 of those engines in to BES now, and they're going to start working on them. That engine has a lot of potential. The first guy that comes out with an aftermarket head for the Godzilla is going to be king.
Really?
Yes, that thing needs an aftermarket head so screamingly bad it's not even funny.
Well, what are you doing sitting here talking to me on DragBoss Garage then?
I've petitioned people to do it, but the economy right now is not really conducive to new projects.
Oh yeah, here's one. This might help you out if you ever need it. I don't know anybody else. Crow Welding in Hudson, Wisconsin does great cast iron welding.
Okay.
I would think of Crow Cams from down under. Can you make a small block version of the AC51?
Yeah. A guy has already contacted me and asked me about that. And I would love to.
How would it compare to what's out there now?
Well, if you could shrink it down and actually attain the level that we are now.
Yeah.
I mean, you could make 1200 with an NA 400 pretty easily.
Wow.
I mean, the only problem with that is the bore space. If a 400 bore space is inadequate, and it's like the Mopar has a 4620 bore space.
Okay.
Okay, so just that bore alone, that's 20 horsepower.
Jesus.
Yeah. That's not something you're going to really overcome either.
And here's another. This is an LS7 thing. I don't know much about it. It's almost too good to be true. 12-degree raised runner, 285cc factory runner, 1.8 rocker ratio, beast of a head.
Yeah, it is.
Okay.
I mean, when the LS7 had come out with titanium valves, no less, coated titanium valves. I mean, when that thing came out, I'm like, oh, but that thing had as much more potential even than any engine I'd seen. It's so easy to make 650, 700 with one of those things.
What do you remember about this? Now, people have talked about, the canted valve arrangement. And somebody said that Mopar did it first back in the 50s.
Polyport, yeah.
I thought it was more been done with design, but that was designed 60 years ago. They never followed through with it. They only made a few motors or engines and never really went anywhere with it, from what I read.
Yeah, that reminds me of the the Mach 4 project, which was 1964, which is what they called the porcupine head, which is what we now call the big block Chevy head.
Okay.
But those prototypes were the ports, and that was all developed by Smokey Yunick and the GM engineers. And there's only like 10 sets in the world, and they kicked them out of NASCAR. They tried to run them in NASCAR, and they made them illegal in NASCAR. So GM took it back and actually made the production head out of it. But that head, I actually got a port set of those things. And there's only a handful in the world. There's only like 20 manifolds and like 20 sets of heads in the world. And that thing had port designs that rival and are better than the current big block Chevy.
Really?
Yeah. The valve train was shit, but man, the port layout was awesome.
Wow.
It's kind of funny how things like that are lost to history.
I never even heard of that head. You know, I've heard of porcupine head, but not that.
The Mark IV. Look it up.
Yeah. What do you think about Smokey Yunick? I mean, as far as like a, you know, mechanical genius, or if you want to call him genius or innovator.
He was.
He was good. That good.
My God, look what he did in his time with the technology he had available. Holy crap.
Yeah, see, I don't know much about him. I should do a video on him, research him a little. I know he wasn't afraid to make money. I can tell you that. You know, nothing was free with Smokey Yunick.
He wasn't afraid to try the wildest ideas he had in his head either.
Mm. Yeah, like the fuel line on his stock car that was like, I don't know, 2 foot in diameter, some crazy thing that held all this fuel.
I mean, his first flow bench was an oil pan with a hole in it and a vacuum cleaner, and he mounted the head on the block.
R.I.P. Smokey from a Ford guy. Let's see. Oh yeah, now I don't know about this will be a quick one, easy for you to answer. JC51 for the supposed 408 Godzilla.
I'm not following.
I think what he's saying is put a JC51 on a Godzilla motor. They can only 408 cubic inches. I don't know. Let's see. Do you have any experience with Bud Moore NASCAR Trans Am Cross Ram intake? If so, what was the reasoning for its design and use?
No, I don't. I don't think I've ever worked on one.
I mean, I've seen them. Chevy had like the Cross Ram type stuff too. I don't think they work that well.
No, they don't.
At low RPM, they're only good for probably racing 5 up.
Mm-hmm. Yeah, they're only good for lower engine speeds.
How about this one? For a big block Chevy nitrous engine, which do you prefer, 9-degree or 14 or 16-degree head?
Okay, it depends on how much nitrous you're running, but you're going to be in the 14 to 16 range. For God's sake, don't go with a 9.
There you go.
It's too fast to burn. The whole idea is to control the heat. And you can't control the heat with a small fast burn chamber. You've got, and a 14-degree combustion chamber is, you know, you can run that up to 600, and a 15 or 16, you could put 1,200, 1,300 shot of nitrous to it.
Wow. And I thought 150 horsepower shot was a lot when I was a kid.
And pro mods are, I think, about 12. Sorry about that. And I have done a lot of work in that area. So hands down, this is the truth. A bigger combustion chamber is easier to manage with nitrous. And with an NA engine like the Ford or Pro Stock, those categories, we do everything we possibly can to decrease the chamber surface area and increase the burn speed and the quench area and everything else. And in a nitrous engine, we do it the exact opposite. We do everything we can to slow it down.
Here's a secret question.
Depending on which valves you use, you could use anywhere between a 2.575 or a 2.600 intake valve, and they'll move anywhere from 630 to 640.
Wow.
And they'll move about 435 to 440 at a half-inch lift.
500.
No, 400. 430.
That's amazing.
430 to 440 CFM at a half-inch.
Jesus. I doubt you're going to, I'll put it up here just because people love to talk about this stuff. Do you have any experience with high port Cleveland heads, and how much of the flow can you get from them?
Which heads particularly?
They're just saying like a high port Cleveland where they cut off the exhaust ports and put on the exhaust port plate. That's what they're talking about. You know, how much flow can you get from? Basically, from a Cleveland intake port, you might get 360, 370.
Yeah, with a 2200 valve, you're going to be in the 360, 380, and with a 2250, you're going to be in the 380, 400 range. I mean, you can get 400 out of them, but 380 is about normally as good as I see.
Okay. Let's see.
And that's with filling the floor in with epoxy about 3/4 of an inch and getting the airspeed up.
Now, here's a good one. This is a good one. Smokey was the first person to make a lap at Daytona, and he really pissed off Bill France when he drove his race car and ran around the track at the press opening. I could see that guy doing that with his damn hat on, you know, that cowboy hat and a pipe. You might know this off the top of your head. Does a 429 Super Cobra Jet head flow better than a big block Chevy?
No. Nope.
They have a problem with the exhaust, just like the Cleveland.
The problem with the 429 SCJ heads versus the big block Chevy is, you know, you have a bore, so you try to place your valves in that bore. And like an unlimited engines, we put it right on the bore center line. So that gives you the most area for the biggest valves possible. The problem with the CJ heads is the valves are back off of the bore center line and rotated and cramped into a corner. So it offsets the whole combustion chamber. It limits valve size. It's horrible for burn rate. They're a problem. That is
unless you change the location of the valves, right?
But Kazi has heads where he has moved the valves and they'll move for 60.
Okay. Let's see. Yeah, that's what we were just talking about. 430 CFM at half inch. That's crazy.
And I've seen 447 with a little smaller throat.
Well, this is we talked about this quite a few times. Is how much? 1425, right?
What?
How much horsepower is 499 cubic inches making with a JC51 head?
I'll say with one carburetor and a wet sump, 1420 is about it. I mean, for right now, until they raise the RPM range on it. If we can feed it, the carburetors might become quite limiting. We don't know that yet. Let's just say that he's not shifting it very high right now. He's not stalling the converter high, and the converter has about 7% slippage. So to say there's a little left in it, yeah, there's a little left in it.
Do you have any experience with the Higgins heads or the Hammerhead Hemi head for Cleveland?
Yep. And which Higgins head are you referring to? But the Hammerhead Hemi is a really cool little head. I like that head.
That can make some serious horsepower.
It's got the combustion chambers closed up. You know, and those things will move 500 CFM. That's nuts.
Yeah,
it's a Hemi. Yeah, it's got a lot of cross flow, but you can still manage that. Shrink the exhaust down. Don't use a big exhaust. God dang, people over exhaust stuff so often. I mean, the quickest way I know to gain about 15 foot-pounds of torque is on a big block Chevy is take the 1880 out and put a 1850 in there. It'll automatically move more air because the valve's unshrouded, and it'll pick up power across the board. There
it is. Another tip from Darin Morgan. Let's see, what's this? I don't know what I've talked about this. I had my aluminum block and parts done for my DragBoss with this vibration thing they use on a lot of circle track motors where it sets on a vibration table. You know what I'm talking about?
Yeah, I really can't speak to that one way or the other.
I can only go what they told me. Said it makes a big difference. So
I have heard that it does. I've heard positive things about it. I haven't really heard any negative things about it, but I don't have any experience with it.
Let's see here. Scott, thank you. I appreciate that. You know, like I said, you know, like this channel, like this video, this live chat, subscribe. I got a lot of subscribers with the past few videos. Like I said, the money, half of it goes to me for the DBG that we use to build these projects. And the other half I give to Darin because you've taken a lot of time from your family. We've been talking for 2 hours and 29 minutes. I think this is the most people we've ever had, 274
Cool.
at one time. You know, I see a lot of live chats here. They got 10 people, 15, maybe 60. This is one of the largest ones I've seen. And I thank you guys for spending some time here with us. Thanks, Scott. Appreciate it. Now, here's a good one here. Let's see. Do you have any experience with McCarty Pontiac Ram Air 5 cylinder head? Do they work with push rod in the middle of the port? Also, have you worked on the DCI split port Ram Air V head, 5 head?
Again, I can't comment on anything in the shop or anything that I'm doing. And since he has involved me in a small way in that project, I can't talk.
Okay. Now, the last I knew, Pontiac made a Ram Air 4 head. That's the most head they made. I didn't know they made a 5.
I will say that in the previous attempts, the push rod in the middle has been a problem.
Problematic. It's like the tunnel port. Anytime you put tunnel port, that's just blocking the flow, right?
Yeah, it's the management of the wet flow of the fuel suspended in the air is the problem, because the fuel will hit that and shoot off onto both walls, completely deatomize, lean the engine out, and it'll detonate at high engine speeds. I mean, that's what we saw with the tunnel port heads. And the tunnel port heads that Junior Johnson did for Ford back in 1990 flowed 400 CFM back then.
Wow.
Yeah, that was stunning. And they were 150 horsepower down and detonated the pistons out every time.
Okay. And I think this is pretty easy to answer because it goes along with the 500 cubic inch, carburetor wet sump versus dry sump, I think.
That's not to say on the tunnel port deal, this is not to say we can't make it function.
Right.
Which is what he's doing. That's what he's trying to accomplish. So we'll see.
Make anything work if you put the time into it, I guess.
There's more than one way to skin a cat.
Hell yeah. Is there a good estimate of how much power a motor will pick up by switching over to dry sump with no other changes?
Yeah.
Yeah.
Yeah, usually a wet sump over a dry sump is anywhere from 20 to 40, depending on how bad your wet sump was before.
Okay.
And how good your dry sump is now. So, yeah, it's about 20 to 40.
Depending on the application.
Yeah. And the higher engine speed you have, the more it's worth.
Can intake manifold pick up head flow on a flow bench?
Well, can it? Yeah. Can you port it for more airflow than you can possibly use? Yeah. More times than not, that's what happens. The runner really doesn't have to move any more air than what the port can move. You think? So the runner itself is just controlling the volume, airspeed increase into the port. There's a lot of other factors too, but we don't really flow them on the flow bench. That's not something you will see us do unless they're attached to the cylinder head. Now, we will flow them in some cases to make sure they'll flow what the port will flow. I mean, you have to be at least 105 or some percent over the runner. If the port flows 380, the runner better move 400 unrestricted, or it becomes a restriction.
Okay.
But we usually do not flow them. It's usually just a size deal related to airspeed.
Then you get to the people that are, spending, $200,000 on an engine. They're going to do that.
Oh yeah.
Every little piece.
Yeah. As far as, in something like Pro Stock, you would put it on the bench. As a matter of fact, I've done shear flow studies on them and a whole bunch of other things. I mean, you're constantly working on that.
I think this is a tough question to answer, but we'll throw it up there.
No, I really haven't worked. The only insight I can give you into E85 is what other people have told me. I have not worked with it.
Thank you. We appreciate it. These chats are invaluable. Make it worth their while, ladies and gents. Cheers from Australia. Thank you. It does. This is the stuff that you're just not going to find anywhere. Someone that's got the time, the knowledge and experience that you have, Darin, to put it out in layman's terms for people to listen to. I mean, you talk so down to earth. I can understand it. It's great. Thank you.
I mean, I'm just no head porter. It's not like I'm just a gearhead. I'm just a gearhead.
Damn, let's see.
No more fancier than that.
I don't know this one here. It's mountain motor Ford Pro Stock engine, a 5,300 bore space.
What about them?
Is a mountain motor, I think they're asking that, is mountain motor Ford Pro Stock engine a 5,300 bore space?
Under the current rules, actually, I forgot. I haven't dealt with one of those engines in a decade. I would expect that they were still 5.3.
A resource for
they were originally 5-inch. They were originally 5-inch.
They were.
Yeah.
You just got to look, man. They're all over the place. You know, I have a Cleveland block that I've had for 35 years, short block, sitting over there in the corner. I've always wanted to use it, but I never have. It's just been sitting there. Come and get it.
See, Mountain Motor Pro Stock is what happens when you run out of bore. And you just keep cramming as much stroke in that son of a bitch as you can fit.
Okay.
You know, it's kind of funny, but the more stroke you put in those things, the more under square the engine gets, the less power it makes per cubic inch. But if you add 20 cubic inches and you're making 2 horsepower per cube, that's still 40 more horsepower.
Oh, sure.
But if it was unrestricted, it had the right bore, it'd be 80 to 100 horsepower.
Big bore, short stroke. Let's see here. Have you ever flowed a head with the intake valve removed and it flowed less air than the valve in the head at max lift?
Ah.
Have you ever flowed a head with the intake valve removed and it flowed less air?
No, I don't recall ever seeing that happen. That would be I would like to see the port that actually did that.
Yeah.
I mean, because we use open port flow coefficients. In other words, flow the port without the valve in it.
Yep.
And that is 100%. And then put the valve in and your coefficients rated off of that, your efficiency. So that is one way to do it. But no, I've never seen that.
Darin, were you involved with the Profiler big block Ford head design, and is it better than the big block Chevy head?
Okay, yeah, that was my baby. The standard C head and the canted valve version. I did the canted valve version before I left, and it didn't come out until 8 years later.
Jesus, what's it do? Just sit around and paper?
Well, it takes time and money to produce all that stuff.
Okay.
So. I mean, when I left Profiler, I had 5 prototypes on the shelf.
Did you really?
Yeah. Is it better than the big block Chevy head? A conventional big block Chevy head, like even a 20-degree cylinder head? Yeah, hands down it is. I mean, it would outperform any 20-degree cylinder head.
Until you make the big block Chevy symmetrical port like they did. Right?
Yeah, I mean, you're talking about a big block Chevy 20-degree head will move 530, 535, CFM. Mm-hmm. With a bigger valve, maybe 550. And those heads will move 580. So you're not going to compete with that. Plus, it's got a smaller, faster burn chamber. That's instantaneous 20 foot-pounds of torque. You've got better exhaust. You've got higher RPM potential. Yeah. It's all around. It can make more power. On average, I would expect at least 40 to 50 more out of it.
If a turbo can increase power by increasing pressure and temperature, according to physics, can you make the same power by increasing the velocity, dropping the pressure and temperature?
Okay. If a turbo can increase power by increasing pressure and temperature, well, it doesn't increase pressure and temperature if you're going to make power. The whole idea is to keep your inlet temperature down.
Cool, yeah.
You want to gain the pressure, but you don't want to gain the temperature because you're just moving the molecules further apart. The whole idea is to compact them together. So inlet temperature does become critical. So you do increase power by increasing pressure. According to physics, you can make the same power by increasing the velocity, dropping the pressure, and the temperature. Okay. You can only increase the velocity up to 690 feet per second before you go into what they call a subsonic choke, where the engine literally, it can accelerate the air further. It can do that, but it's using more energy than it gets in return from cylinder fill at that point. So it's not really a choke per se, but it is from a power standpoint. It will increase airspeed. So you can't capitalize on that increased airspeed on an NA engine. And the increase in velocity, dropping the pressure is directly proportional to increasing the velocity. So that's one and the same. And dropping the temperature. Now, yeah, you can keep dropping the temperature to a point where the vapor pressure, you can't atomize the fuel, and that is about 70 degrees Fahrenheit. I hope that summed it up.
I think it did. Let's see. I like this one here. Darin's the best in the business. If anyone reputable talks about this kind of stuff, Darin's word and the name is the benchmark for what's right and wrong.
Oh, don't do that. Don't put me on too high a pedestal. I'll fall off and break my neck.
I can fix that.
Yeah, I'm very seldom right all the time.
Let's see. What heads and intake would you recommend for a turbo methanol car, single 118 millimeter or twin 94s?
What type? What brand?
Yeah, what heads and intake? I don't know.
Okay, well, if you're going to use a turbocharged, let's talk in generalities here. If you're going to use a turbo, the best thing you can do is use the exact same cylinder head that you would use in a normally aspirated engine. No different, except maybe put Inconel valves in the dang thing to withstand the heat. Mm-hmm. Because a properly turbocharged engine's pressure differential side to side, that engine thinks it's just at a higher atmospheric pressure. Okay, it doesn't have the differential pressure. If it's equal on both sides, it's just raise the pressure accordingly. So it just thinks it's on. It thinks it's in the Mariana Trench, 1,000 feet below the engine or below the ocean.
Yeah. Sea level.
And methanol acts as an intercooler, which is good. So what heads and intake? The intake itself is always situation dependent, engine dependent. Really have to know what you're trying to do in order to dictate what you have to do with the manifold. What's the engine's going to be used for, RPM range, yada, yada, yada. But you can shoot me an email and ask me that question. I'll answer it. I just need more information.
Now, we were talking about that flow in the head without the valve. Racer D says, I've flowed plenty of heads with the valve removed, and yes, they flow less air.
See, I want to know what ports they're talking about, because the ports I deal with don't do that. So it would be interesting to know, guys, what you're dealing with there. What kind of ports you're dealing with. Now, my ports are always about at 98%, or the valve, it's about 98% valve versus no valve. So with a valve in it, it'll flow about 98% of what it will without the valve in there. Again, once it hits 0.45 LD ratio, the discharge coefficient shoots up, so it's like the valve isn't there anyway. So by 1 inch lift, that valve is not a factor anymore. So by the time you're at 1,300, 1,350, you're flowing all port.
DRC was a 4.9 when released, and 4.9 was required in Pro Stock.
Yeah, stand corrected.
Ramon, thank you again. We appreciate it. 351 Cleveland, 375 stroke TF's modern FI. How would you compare that to the LS? I don't know. I have a hard time trying to compare that.
Yeah, that's hard.
What's it?
It depends on what metric you want to dictate that.
Right.
Flow, valve area, power potential. There's a lot of ways to address this. But from a raw power potential, pretty damn close.
I mean, that engine right there, just looking at, I don't know anything about the cam, nothing, but just looking at those numbers, that thing could probably make, without a ported head, you're probably going to make 580 or 600
I'm thinking of the bore and the valve area and the cam cores and everything else to extract that. They're dang close.
We'll have to revisit that one, maybe get some more information on what you want to do. I don't know about this. How do you feel about Liberty's heads copying dart design?
I don't know anything about it. And imitation is the highest form of flattery.
Isn't it, though? Rod and stroke ratios. Your thoughts, pros or cons of numerically high and low ratios?
Yeah, I always like this question.
They always worry about side loading. Are you loading those cylinders when that, you know, with a with a ratio rod to stroke?
It's not as detrimental or problematic or even an issue that most people think it is. If you're between 1.5 and 1.7, you're probably going to see very little, if any, difference depending on the engine you're dealing with and where you're running the engine.
Right. RPM.
On drag engines, yeah, it seems that they accelerate quicker on the racetrack with a 1.65 or a little lower rod ratio. And it is a fact that if you go above 1.9, if you're up into the 2-to-1 rod ratio range, the induction system gets lazy. You have to shrink the cross-sectional area, increase the airspeed, increase runner length, decrease taper. You got to do a lot of things to overcome the laziness, the dwell. And people keep thinking, well, it dwells at top dead center, so it's going to help with cylinder pressure and you're going to get more torque. But what they forget is that it dwells on the intake stroke too. And that causes what's called a port pressure lag. So that's a whole big problem, which is why, you know, you want to go as over square as possible, bigger bore, shorter stroke in order to get the engine speeds up. And in comp, you know, you have classes where you can run a 265 to 305 cubic inch small block. Well, we built many of those engines. And the ones that went out there and ran fast and set the records were the ones with the smaller bore to get the piston speeds up. You could go to a 4200 bore and we're at 4060 because we didn't need the valve area. So you're increasing the bore, and by increasing the bore, you're lengthening your rod, and your rod ratio hits 2-to-1, and now you can't compensate for that. So, and also, all these NA engines go through the traps at about 5,800 to 6,200, maybe 6,500 feet per minute mean piston speed. Almost all NA engines do that. And with a high bore stroke ratio like that, high over square, you're going through the traps at like 5,500. Well, hell, endurance engines are 5,500. You're not going to move any air through the engine that way. It's not going to accelerate very well. It's lazy. So is there an ideal rod ratio? No, there's not really an ideal rod ratio, but there are rod ratios for specific instances that operate a little better than others. And to go above 1.8 is almost always a disaster. And where people get into trouble is they have this ideal rod ratio in their head that they heard from somebody. It's like, I have to have a 1.75 rod ratio. And then they screw up the piston design and in order to do that. And now they have a high CH, the piston's top heavy, and it loads the skirt harder than if they would have just went with the rod that fit. So what rod ratio do you need? I can tell you, make your piston as compact as possible and as stable as possible. And then whatever connects that to the crank, that's your rod ratio you run.
Thank you. Is there, this must be an LS guy because I like his initials there. Is there a limit to bore size where it becomes too large with respect to flame travel and filling the chamber at high RPM?
Well, the bigger the bore, the harder it is to get it to burn completely and quickly. I mean, the amount of length it takes to go from one side to the other. Yeah, bigger bore engines are harder to deal with. And that's one of the things, it slows the burn down, and it's harder to get a complete burn and a homogeneous mixture into a big bore. I'll say that. Is there a limit on bore size where it becomes too large? Haven't found it yet, but I'm sure there is. And too large with respect to flame travel and filling the chamber at high RPM. No, the bigger bore doesn't really hurt chamber fill. It actually helps because you can put a bigger valve in there. So you're not hurting in that aspect at all. With respect to flame travel, yeah, that's always a problem. I mean, that's why you see that flat quench area. And on modern pro stock heads, there's a little bit of a taper on there now because we actually had a little too much quench area.
I heard Matt talking about that. Matt Beineman talking about that in his cylinder heads.
It can actually cause friction pumping losses, because it's like you take two flat plates together and slam them together. The surface tension, it takes force to pull those apart. So when you're kissing the cylinder head at 9,000 RPM, it's got to pull itself off of there. And yeah, it's a couple of horsepower. It's not much, but every little bit helps. You put that in there, and it also helps to move we're assuming it helps move the air to the center of the combustion chamber and helps mixture motion and other things. It does a lot of things that help.
Now the flame front, doesn't it only travel at one speed? Didn't you say like 70 miles an hour or something?
An unmixed air fuel ratio is about 70 miles an hour.
Okay.
But you go up by factors of
exponentially.
Yeah, when you get mixture motion in there, because you're taking the flame over here and you're blowing it over here, and it's igniting everywhere else. Without mixture motion, there's no way we could attain engine speeds even close to what we have now.
I like to see those. They're like two-stroke motors or lawnmower engines that have like the plexiglass cylinder head on it, and you can watch the flame front and watch all the combustion process. You ever see that?
A lot of what we do is designed around the fuel that we have. I mean, when pro stock rules changed throughout the years, so did the combustion chambers and the way we address things. Because the older fuels, you could compress, a lot more, and then they changed the fuel, and the VEs got high, and the octane of the fuel was low, and the light ends were real high, so it's detonation sensitivity. So we had to change the combustion chamber there, and then they went to C25, and then we, the fuel dictates a lot of what we do too.
Let's see. 268 people who've been here 2 hours and 51 minutes. But we only have, let's see, a few more minutes. We'll break the record. Here's a good one for you. I don't know that head.
No, I haven't.
I can't believe how many conversations are going on the side of this, this feed that me and I are talking, and it's hard to keep on both of them. Let me see if this works. Would be a small block Ford all-out race type build coming from the 2V mod motor world. Just trying to understand, so small block would make 2,000. That's what he was talking about before, but I forgot the rest of that question. Do you remember this question at all, Darin, or no? I'll see if I can find it. Sorry, guys. Let's see. Oh, yeah, this is what it was. So read that. What would be a small block Ford all-out drag race type build coming from the 2V mod motor world? So just trying to understand some just small block Ford stuff.
I have never dealt with mod motors.
No, he's coming from that, and he wants a small block Ford that'll make 2,000 horsepower. So here's what he's asking.
Okay.
What heads and intake would you recommend for a turbo methanol car, small block Ford?
Well, the SC2s, I mean, they're bulletproof, strong cylinder heads.
Oh, yeah.
And they have all the flow potential you'll ever need. That would be an easy build. Make
2,000 horsepower?
Oh, yeah.
What would you put on a single 118 or twin? I like twin 94s. I don't know.
Well, I'd have to look at that. I can't say right now.
Let me keep going. We'll get back and catch you up.
My brain's getting tired.
Mine too. Let me see. I don't know about this. Darin, what do you think of Ford's engineering thought process was behind having such large ports on the Cleveland when everyone likes them smaller?
Yeah, that's been a question for many decades, and I can't answer that other than they just didn't know any better. I mean, back then it was, porting heads was a dark art.
Oh, yeah. Bigger is always better, they thought.
It was black magic. Nobody knew what the hell was going on. And, you know, it stands to reason a bigger hole will move more air. So let's just put a bigger hole in there.
There it is. They didn't think about velocity then. You know what I mean?
No, they didn't even know the concept.
Let's see. Darin, do you like the fact that Ford produced 8.2, 9.2, and 9.5 and 10 deck heights to maintain proper architecture in the various Windsor and Cleveland blocks rather than small block Chevy standardization?
Do I like it? Yeah, absolutely. I mean, it just gives you more latitude.
Now, what's a small block Chevy? What's their deck height? 9?
9.
Okay.
Small block in just about any deck. I mean, Tony's building some 572 cubic inch small block Fords right now. So you can imagine what those decks are.
Wow. Well, I mean, they got to be what? 10.3 or something?
Actually, I don't even know exactly what they are.
Wow.
I'm back there in the headroom freaking pumping out heads all day.
Let's see. Darin's thoughts. Well, we'll put it up. Darin's thoughts on rod ratio are the same as George Bryce. The connecting rod connects to the piston and the crank, and that's about the end of it. George Bryce.
Yeah, trying to place any more emphasis on it than that will get you into trouble.
He does motorcycle stuff, doesn't he? George Bryce?
Yeah.
Doesn't he?
Yep.
Let's see.
I mean, you're talking about pro stock Harley heads move 700 CFM of airflow.
Do they really?
Yep, sure do.
Wow. That's crazy.
714 is the most I ever seen on one.
Here's a good one. This might be for you. Do you have any preferred board stroke ratio for a 300 cubic inch NHR comp engine?
300 cubic inches?
Mm-hmm.
Going over a 4060 bore with piston speed's a little dicey. A 4125 is the biggest bore I go with on something like that to try to maintain some piston speed in that thing, and reduce the rod ratio down, and to have an 8.5 deck. I mean, you really have to have an 8.5 deck if you're going to build a true all-out comp engine with 300 cubic inches. Otherwise, you're just pissing in the wind. You'll never get the valve train stable. Everything will be, yeah, you have to.
Here's a general question. We'll use a Cleveland since that's what I'm familiar with. A 4030 bore. Let's say you make that a 4080 like the Pro Stock motors did when they furnace brazed those blocks. How much do you pick up going from 4030 to 4080 horsepower? Is it the valve unshrouding the valve that much?
Yeah.
Could you pick up 50 horsepower? 100?
Going from a what to a what?
Let's say a 4-inch to 4080.
Yeah, you gain 50.
Okay.
With valve area and RPM you raise. Yeah. Yeah.
Thanks, Anthony. He works at the Shelby Museum in Las Vegas. So if we're ever out there, Darin, he's up there and he'll take you on a tour.
Awesome.
Right, Anthony?
Yep, on that.
Here's one. Let's see. Well, we'll stop. There's only a few minutes left. We'll stop at like a little after 3 hours, and then we'll be good. How much compression is too much compression on methanol with 30 pounds plus? Would it be wise to lower compression to add mixture volume?
I would call Kenny Duttweiler and ask him.
Or we'll get Kenny on here and we'll do a live chat.
Because I don't deal with turbocharged stuff.
Okay.
I mean, we built them. We built supercharged and turbocharged and everything else. But when you're really leaning on it like that, he would have more insight into that than I would.
Thanks, Tyler. David Bowers. Darin, does the chamber you did on the Profiler small block Ford head want minimal quench? I think that's 40 thousandths or no quench.
Yeah. If you're talking about piston to head clearance, that's really, you're talking about piston to head clearance.
That's what I think he's talking about.
You're always better off as tight as you can get it. And how tight you can get it is up to the components you're using, the clearances you're using, and the engine speed.
I'll tell you, Cleveland's used to
I can't tell you that 40 is going to work. I don't know what your engine speed is. I don't know what components you have or anything else.
They'd be close. They'd be hitting the deck sometimes. I think I would have
40 is damn close.
Yeah.
I mean, I mean, I know stockers that'll turn, 7,500, 8,000 with 40, but they also have steel rods and tight clearances and really stable pistons. So if your piston's not stable and on the rock, it'll freaking hit too.
Yeah, I watched this. You've probably seen this, Darin. When he put the clear, put him on the engine on the dyno and put his finger in there.
Yeah, he gave me those videos. I still watch them from time to time.
I mean, that thing could tear your finger off. I mean, there's enough force.
Hell yeah, he said it felt like he was going to break his finger.
Oh yeah.
He had to pull it out. I don't think he said he got it past 6,500 before he had to pull it out.
I asked him about being on DBG before, and we talked, but I haven't talked to him in a while. I'll get him on here. Oh, here's what you were talking about. Did GM engineers design the canted valves with a mystery big block 427 that eventually evolved into the Mark IV?
Yes. Yeah. Yes.
Now, I will say this. Somebody sent me information. I'm going to do a video on it. But the Cleveland head, the canted valve setup, there was two guys that put in bids on what they want to do. Someone sent me an article on it. And Bill Gay is the one that designed the head, if I'm not mistaken. You know who I'm talking about, Bill Gay?
Well, I know the name, yeah.
That's what I read. I'll have to do some research and do a video on it.
I'd like to see that new Ford head Matt has. The thing looks evil.
I'll get him on there. We'll have him show us about it. I'll text him tomorrow. He might even be on here now. He is. Heads up, Matt. I'll get a hold of you tomorrow. But look, we've talked now. It's 3 hours and 1 minute. And I just want to wish my daughter happy birthday, Izzy, and my wife, Andrea, and Elena for letting me come out here and spend time with Darin, 3 hours of her birthday time. I'm glad her friend came over for the first time to stay overnight because that keeps them occupied while we can talk for 3 hours and answer a lot of questions, teach people stuff that they're not going to find anywhere else. I really appreciate that. You know, someone's complained that I give too many shout outs. I try not to do a lot of shout outs here and take your time. But I think it's important to recognize people. That's what makes people work hard, recognizing them, showing that their efforts, just like this engine. This is something that you've worked on for who knows how long when you originally put the time into it and then have it to be the rug pulled out. Sorry, buddy. Now what? And now it's come to fruition. And this is where you shine.
I literally forgot about this thing and parked it in the corner. And I didn't think anybody'd ever use it.
On the beginning of this, I put a trailer, which is a video that you put in to add while you're waiting to see the show. So I put the one where you did the secret A3 head, where you turned it from a Cleveland combustion chamber into the modern one. I put that video up. I heard a lot of comments. They just can't believe the time that you put into that head. You know, I'm really pumped. That engine's going to be coming about. Hopefully, with the parts are in, like the cams there, the pistons are there. I had the rods there and the crank. I don't know about the valve trains there too. We ordered the valves. Remember all the titanium valve? It's all ready to rock. It's coming down. So appreciate you guys tuning into DBG. We're going to call it quits here now because him and I are both tired. My throat
I'm tired.
And here, I'll answer this one question. This one guy's asking, and then we'll be done. Because he asked me, why did you use A3 on Tim's 409? Not as highly thought of way back when the later heads came out. Short turn on the exhaust was tight, intake too big. Did you move the push rod over?
You use that head because it's a challenge, just to see how much we can get out of it.
That's what he said. He says, I want to just go crazy on this head. I said, all right, let's do it. That's why we used it. You know, and you did move
I'm wired that way. I'll go off on any tangent. I don't care. I
think you told me you had 80 hours in that head, those heads, something like that, or 100 hours.
Welding. I think it was right at 40.
Oh.
Yeah.
For one head or both?
With the welding in the chamber and everything.
It's nice. I can't wait. Yeah, here's one more for us. We're going to call it quits. My brain is dangerously close to reaching critical mass. Thanks, Darin, for teaching this old dog new tricks. Great segment, Tim. Thanks.
Guys are welcome.
It, Wilson. Appreciate it. Let's see if we're going to end this broadcast. One quick note. Now, we talked about doing videos on induction right from the development. This is a perfect example. This engine right here, this project. do you have other things to talk about in regards to intake manifold or cylinder head development that we didn't touch on here? Maybe for a specific brand, like for a Chevy versus Ford or a Mopar.
You know me, I could talk about this stuff for days.
There's your answer, guys. So we'll be back. We're gonna end it now. We'll you guys in the comments write down some stuff that you might want to hear about, or however we get in touch. I try to answer every comment. It's hard. That last video I put up it's over 60,000 views right now. And I mean, there's like 500 comments, and I try to answer each one. Sometimes they're hard to answer. They get in different places. So if I didn't get back to you, I apologize. But I try to keep up on this. So I'll put a link on this video for Darin's channel. He's got a channel with a few videos, and we'll see what we can do. So let's keep going. I appreciate you guys being here at DragBoss Garage. So stay tuned. Thanks.